All right, let's see. Hello, hello, and let's go. And 1 second here. I need to charge thing here. Let's see. All right. So we're continuing with changing the monsters from the previous system to more to this sort of state machine that we have in here now. Here's the state machine for this particular monster, which is very, very simple state machine right now. It's a bit busy here, but it's like here we're sort of having a default spawning state machine that handles the spawning wave stuff, because that is basically the same for all monsters basically. And then we also have some default behavior that is always going to be applied whenever it's stuff like check if we need to set the state to be dead, check if we have taken damage, then we do some knockback stuff and stuff like that. So now this would probably be like depending on the type of damage and stuff like that, but right now the only damage we have is the player actually hitting with the weapon there, so that's the knockback stuff. And we also have like a hook here or a event listener on spawn, so basically a way to say from transitioning when we're transitioning from spawning to spawn. So when the spawning is done, what do we do then? So we set the state to walk to be the default behavior, and then we also start that animation there, and then that's basically, yeah, and then we're on to, so that this is sort of the default thing that it's gonna be on basically all monsters gonna have this types of setup, unless it's like a specialized thing, but we do leave up for specialization here. So it's like, I don't know, I don't like repeating, but this is like maybe sufficiently small that it could be repeated. And then also like some maybe don't want to have knockback, then you know, I mean technically what you could do is wrap all this into a, well, I guess maybe not on spawn, because that is going to be different depending on like which state are you gonna set and what's gonna happen otherwise. So that is gonna be different, but this part is gonna be sort of the same, although this one is sort of a temporary thing, so I don't really need to do that. And the only, yeah, and then the initial, we don't really need a separate line for this, we can just add this here. So that this will basically be a one-liner, and then this is gonna be different for each one, maybe, we'll see. Anyway, so well, we'll see as we implement it. We're gonna see what the differences are and stuff like that, so we can further improve if we want to. But now it's a much more manageable, at least up until now. From like creating a new monster is simply well, before there was a lot of steps involved, but now there's like 3 steps or something like that, so it's like a lot simpler. All right, and once we also have more and more behavior sort of helper functions for different kinds of behaviors, then we can also reuse a bunch of a lot of that functionality to build out behavior in a more quickly as well. All right, so anyway, let's see now. So what I'm gonna start, so this, I'm gonna start with trying to implement this monster here, which is a lot more complex than our previous monster. So this one, yeah, it's gonna be interesting here. So we'll start with making a state machine for this monster here, and so let's do that. We don't need this here. We can instead do this. That should be good. We need MU. All right. Now this is probably gonna be the same. On spawn, we'll see what happens. It depends. Yeah, because this monster is not only gonna have like walking back and forth, it's gonna have like jumping and attacking and stuff like that. So we have to go through the old system to check whatever behavior this monster had and copy that in this style instead. Okay, so if we go to monster, the old monster system, we go to the update function, and we'll go down to the state. And here, this is the same for everything. We already done this as well. And here, like idle, walk, fly. So basically, let's say we go to spawning. The spawning is done, we set idle. So this is what's gonna happen on spawn. And yeah, there's a set idle and then handle state change. And there should be an idle, set idle function on the monster. So if we go here and look for that, then this is basically what we want to do in the on spawn function. And so we go up here and we will say, but this function is a bit different because this function is basically let's say this function is basically choosing a state, a random state based on this. So it's like when the monster is kind of moving around and doing its thing, it can do 3 different things. So either it can do a jump randomly, or it can randomly just stays put for some time, or it can do a walk. So those are the 3 things that it can do. And this is kind of the default, I guess, behavior when it's just, you know, moving around. And so yeah, so this will be a function that will be I don't know, normal behavior or something. All right. And instead of using set state, we are going to say, yeah, instead of ai.state, what we have is the sm state machine.state instead. So state machine.state. Now we don't have a jump state, So let's just create a jump state. There we go. Now we have a jump state. If we're not jump state, we want to set the state to jump. And this is also interesting here. We have a duration for the jump as well. And we also have a direction. But, and I guess that is kind of, I guess that is sort of very specific to the jump, like having a direction for the jump. I guess the direction could also be, you know, set to the monster itself. So if we just grab the direction of the monster and then we can just set the direction to no. Yeah, direction equal to random. There we go. Okay, so now we have the direction behavior as well. And then the other thing is the end at. So the duration here, I've been thinking of having a generic way of dealing with durations for the state. Because there's no way... I mean, if you don't want to bake in the duration, because it's so common. So what I'm going to do is I'm going to have a component that represents the current state duration. And when that duration ends, well, what's going to happen then? I mean, I guess we could have a, in the jump, we could say, we could have a function that is has state ended or something like that. And then if that is true, then we run normal behavior again. Oops. All right. I guess we can return if we really want to end the thing there. So something like that. So we can also set state duration, and that's well, set state end at t plus idle duration. Come on. Okay, something like this. So now we've done that. We can also do set direction we can do this as well. So we get a little bit more you know, declarative approach here, you could say. All right, so let's see. Yeah, so if the state is ended, we run the normal behavior, so then that's the loop. So it will loop, it will jump, go to jump, do whatever jump is doing, then we'll go back to the normal behavior, and we'll choose another random state to go to, and that's gonna be that. All right, so we have this one is basically the same thing, except the state is set to walk instead. All right. So, and then this one is, I guess we could set direction to random as well, and the state. So it turns out, okay, now these things are the same. So basically, whatever's gonna happen is we will set these things. But you can, if you want, have things going on, you know, specialized things going on depending on the state. Wait, but that's not walk. This was idle, that's right. And then we need an idle state. It's so easy to create a new state as well. It's so simple. Just add a new function. Like the signature is the same, so we can just copy that. We do need to put in t there though. Alright, so basically idle is gonna be this. It's gonna be sort of the exact same thing there. I don't think jump is gonna do anything really. We'll see. And walk is just a default walk behavior. Now this we have to change to this because the monster is different. I guess we could do this so we don't have to rewrite that every time, because basically that's going to be the same. Oops. Alright, and then we have the walk speed. We can just copy this and add it here, and there's our walk speed there, except we need it to be 150 instead. Okay. Well, except this one, we don't really need to get this thing here. We can just do this because it's like a constant, I guess. Unless we're hunting, though. Okay, let's keep it like this for now. We'll see how we'll deal with that. All right. Another thing also is that we want to have, the default behavior. We check if we're dead, if we need to do this. We can also include this in the default behavior so that we don't have to say this all the time. We'll see if that's sufficient, because we want to do default behavior on, because that handles like if we need to transition to dead state, or if we need to apply knockback if you're hit and stuff. So we will just do default behavior. Now I actually need T here, so it's a little bit different this time around. Alright, and now we can remove this one, and we have default behavior as well. Okay, cool. Now we need to implement these things. They're not that difficult to do. I'm just gonna add it here. So set direction. And direction is any direction like that. And we will get the direction here, and we will set due to the direction. There we go. Come on. All right. Just a bit, you know, more convenient. And then we have set state and at. So this also needs registry and entity. But this needs and at, and let's see. Oops. Right. So now we don't have a component for this, but I was thinking the same way spawning state has this, we can also replace this state actually with actually I can just rename this to state ends at or something like that. Yeah. And so I'll rename these functions. I'm going through ends at or end at. I don't know what the correct term is, but I like saying ends at more, so I will do that. Also, there we go. Okay, so state ends, yeah. So this will be state ends at equal to get. No, we have it here. It's nice to also just keep the things confined into this file, so you don't need to like export them and stuff like that. Okay, and then this will be, I guess, there is a function which is like get or add, I think. Yeah, so let's use that because it might not exist. So yeah, then it's just a convenience, so we don't have to add it manually first, and or check that it's there or something like that. Let's see, and then ends at equals to ends at. Okay, and then there was another function, has state ended. And we will get this and return. Oh yeah, we need a t. And we'll return if ends at is less than or equal to t. There we go. What? Oh. Okay, I'll say C for components. Okay, so now we have those things. All right. I was thinking here, like, since this is so small and maybe doing something like this could be feasible. Less things to look at, less, you know, I don't know. It's like a ternary almost. Idle duration. Oh, where was that then? Oh, it's over here. Okay, let's move that out here, and then I will rename it for the new convention. Okay, I don't know actually if I like this or the other more. It's like the other is making it very clear that this is like a constant as well, but whatever. Duplicate. Okay, yeah. Let's remove that. Okay, so I think now we have these things here. The thing is also though that we need some sort of function that handles what's gonna happen when we transition, like on the transition point. So at this point, the state has changed. Now in the old version, we had a bool flag that was like whenever, so we had a special set state function, and when you call that function, it set the flag to true. And so then we know it, okay, now somewhere the state has been changed, so we need to handle, it's like an event happening, like the state has changed, so we need to handle that event. And if the event is jump, for example, then we initiate the jump, so we actually do the apply force or whatever to get the jump done. For idle, it's also like playing the animation, playing idle animation, playing jump animation, playing the walk animation. So there are some things that should happen here that we don't really do. So, and we can't do it here because this is like the ongoing function that's update function that gets called every frame. So what I'm thinking is having a similar setup, because there's multiple places where we set the state here, and we should probably yeah, because we don't want to copy this every time we want to set the state to walk. We need to copy these two. So what we could do is well, one thing we could do is have set state, like specific functions to set the state, like set state and we get this machine here to set the state on. And then we we need these things as well. Okay, but then we also need the state to be the state that we're gonna set as well. So new state, which is a constant state function. There we go. But we can switch on the new state. No, we can't. But can we? Like, can you do this actually? Yeah, because then it's like you can also do with if, you know, but I was thinking maybe doing it with the state. So let's say it's idle, you know, then we do something there. If it's walk, we do something there. If it's jump, we do something there. So this is like the behavior that's happening in the transition. Like it happens once when the state is set. So for example, walk, now we can put this part in here instead. And we also, at the end, we also set the state to new state as well. So here, instead of setting the state like this, we say set state to walk. All right. Oh yeah, we need T as well there. Okay. You know, and then the same thing for idle. Just like the idle animation. Jump. I'm not sure if there actually is a jump animation, but yeah, and then we do the actual jump thing here, which we do have these things. Let's move these out here. They don't need to be public. Where is this actually used? Okay, I think it's like in here. Yeah, calculate jump vector. So this is like a common function. I'll put this in the monster utils instead. All right. Okay. Yeah, this is like the generic handle state change. So when we jump, we do set the animation to jump. All right, the looping is false here. That's right. So there's basically going from this is the same for every monster. Now we're flipping it around. But the things that are gonna be common, we can have default behavior built into a sort of default function instead. So yeah, and here you can see this sort of the same idea here, except it's like handled from a shell around the monster behavior instead of the monster itself handling the change here. So it's more visible. So we will do this, and actually I will put that in here and have this guy just jump. And what do you need for that? Well, we'll figure it out. Jump. So we need registry, entity. We need I guess angle and strength. I don't know. strength. Alright. Okay. And so we just do jump there with embed, but now we need the angle and the strength. There we go. Alright. So yeah. I mean, technically we could have this, like when we do these changes, we do it here as well. But it's like, yeah, then we have to repeat ourselves every time. Yeah, so this will be the new state. And then we also set state. New state. There we go. So now we're doing the transition as well here. Whoops. Yeah. Okay, maybe this is actually possible to do this. We'll see. We'll see if this is possible. I'm not sure if this needs like an else clause or whatever it's gonna complain about here. But this is, because this, I'm usually switching on like enums and stuff. This is a pointer to a function, constant functions. I've never done switch on that, and I don't know if it will work, but we'll see. Okay. Is that all we need to do? Well, no, it's not. It's far from it. So, well, it's all we need to do, I think, for the normal sort of walking around behavior. But I think there's also going to be attack, like, and aggroing the player as well. So it's going to be a bit more complicated. It's going to be interesting to see what we end up with here. But also another thing here is we need to change this. So instead of doing the monster AI system, we are going to do the monster utils init monster. And here we have registry entity position. Oh yeah, that's right. We create the entity here first. We have the position, and then we have options. Animations is animation container dot create. Let's see, we have max health, draw layer, what else can we do? Direction, let's just do random, I guess. Yeah, that should all be, oh yeah, hitbox. Yeah. Okay. That is that. We also need to add create to entity as well. Let's set this to 0 to start with. T is not actually used here, so I guess we'll get rid of that. Unless you need T. No, you do need T. So. Oh yeah, after options is T. There we go. Okay. Actually, we could probably do this. No, this. All right, we can get rid of this now. Set idle. We still need to think about the attack stuff, so I'll keep this around. Hitbox size, but this what's left there. We should also have like the aggro. Yeah, the aggro. The aggro behavior is going to be interesting to work out as well. But now the monster should be just once it's spawned, it should be moving around and doing the jumping and walking and all that. So let's now try this. And I think what I'm gonna do is also add this type of monster. Whichever monster I'm currently implementing is gonna be, I'm gonna spawn it in the town as well. I should maybe, yeah, sometime in the future I will work on adding sort of debug controls or something like that, so you can add whatever monster you want or whatever, spawn in whatever you need to test and stuff like that. Okay, monster 98. Right, so I think we will just delete this now because it's not gonna be in here anymore. Should be the same for jump strength here. What else do we need to figure out? 756. Oh yeah, so this is the walk speed. I think we can just remove you there. It's gonna be simple enough. And then we have 730. Okay, let's just add this guy over here. And you are wrong. There we go. Actually, we could just replace all that with jump, call to jump instead, if we want. Alright. Okay, let's disable the debug drawing thing. Alright, cool. So we know that it compiles and stuff. So let's go into the editor and we will add a monster, or we can just spawn over here, I guess, as well. It's actually kind of simple just implementing these things. Whoops. Wait, did I forget to... Oh, I forgot to add the state machine to the entity. Yeah, so we need to add this. Well, we actually need to add a c.state_machine where the state is kit state_machine.initial. There we go. Nope, didn't like that. Okay, here we go. Now we get some more interesting errors here. Else prong required when switching on type this. Okay, is it because it's... I'm gonna guess that it's because it's like a thing that it can't really enumerate, so it doesn't know. So you have to have an else. I'm gonna guess that's the reason. If we get here, I'm gonna just say that this is like compiler error, maybe? No. Because the state should, that should be compiler comtime. Well, maybe it's actually not compiler, it was a pointer. I mean, yeah, because this now this, unless we call set state in these cases, it's not gonna be. This is runtime now. So this is a runtime statement. But if we put the call in each of these, then it's actually comp time known which one we are setting to. But if we don't really need it to be comp time, then that shouldn't. Yeah. So instead of but we could have a compiler error saying that, oh, you cannot set to this state, or it's not implemented, or something like that. We could have a panic or something, I guess. Cannot set state to set state of to invalid or not implemented, something like this. I don't know. And this is the owner, and then we have the. Well, actually, we don't really know what the name. Like we can't get. There's. I don't think the function name. We can get that somehow. So. Let's just do that. Okay. Expected 3 arguments. Okay. So this would be timestamp. Missing struct field ends at. Wait. Master utils 21. Oh yeah. Wait, no. Oh, I see. Well, let's just set it to undefined, I guess. Or I don't know. Let's set it to 0, just in case. And here we will say, instead of this, I'm gonna say set state ends at 2 t plus phone duration instead, so that we don't get some duplications or anything like that. Has state ended, you should return a bool. Alright, so what is your issue here? Value a comp time only known type. Okay, so the function. Wait, why does it have to be comp time only? It's a pointer to a function. Or do you have to do this? Or what? Also, I'm not sure if this works, like the state equals not equal. Okay, maybe that should be fine. 87. I mean, what we also could do is, where is it? Instead of doing this, we can say set state. It was just out. I just wanted to have a little bit less, but now it's like annoying. I have to say address here, but okay, whatever. It's like weird because Sig sometimes like automatically turns a function into a pointer function, and it also differs from like between a pointer to a constant function or a pointer to a function, which is weird because I'm pretty sure you can't modify a function, or I don't know. Yeah, I don't know. I was doing a quick Google there. I couldn't find anything on any discussion on pointers to mutable functions. Maybe I can find it. Modifying a mutable pointer field. No. Okay, whatever. Right. Default behavior. You need T as well now, I think. Invalid record producer. What? Oh, is this an LLVM error here? Invalid record? What? Oh. Okay, I'm gonna take a wild guess that it has to do something with this or this comparison. I'm gonna try this maybe. No. Okay, we'll do this. Maybe this is more correct because now we're actually producing the type that it wants. What if we do this and instead we just succumb to this procedural way of doing things? Now it's going to be comp time null as well. Can't complain about these things at least. Alright. Is that the problem? Or is it something else? Okay, now the problem is here, like I don't see where the issue is. I just have to guess. Right. I don't find anyone who has said anything about this error. Interesting. Is it this part? Like if I remove this. Also, I don't need to check. I don't need to check for jump because we're not going in here if we're jumping. If we're jumping, we just do this. I guess maybe it's like, okay, if you previously jumped, then we want you to idle or walk. Well, we'll see. Okay, was that the issue? No, there's something else. It should be in there because if we comment this out, we didn't get this error before. So it has to be somewhere in that state machine where the error is occurring. Interesting. Well, this was interesting. I wonder if there's a way to turn on like more errors for LLVM, more diagnostics for LLVM. It's also interesting because I thought that this was, well, maybe they are using LLVM for some things, but I thought I was using the new compiler. Hang on, let me check this. What's happening? Wait, why is it so big? Okay, I had it zoomed in. Okay, yeah, they're sponsoring for more money here. Okay, cool. I should probably donate a little bit since I'm using it a lot. We'll see. Let's see. Get started. Documentation changes. I think they updated the homepage or something, or maybe I've never been here. Okay. What do we do here? Source? No. What? Okay, learn. Unstable master. No. Language reference. Yes. So I want to look for the build system or the compiler. I want to look at, here's the build system. Compilation model. No. I probably should go through this entire document because I've never actually done that. Maybe yeah, I'll probably learn something new as well. Let's see. Yeah, maybe I have to go in here. Targets, maybe. No. Appendix. Containers. Because I thought they said that they did the wait, why does this link to master? This should be oh whatever. SIG build system getting started, online relevant. Road to SIG 1.0. Where is it? Okay. SIG 0.15.1 release notes. There we go. Okay. Where is the compiler stuff? There we go. Yeah, it enables it by default. Except on Windows, where LLVM due to linker deficiency. Oh, so we're still on the old one. Okay, that that explains a lot. Right. So what? But okay. So. But then the question is, for the compiler, like I wanted to know if we could enable sort of verbose reporting for the LLVM or something like that, like passing pass options to LLVM or something. I don't know. Multiple linker backends, compiler backends. Yeah. No, I just want to debug this thing. Linker allow sh level. Okay, well, I think maybe what we'll do is we'll try and go through the code and see if we see anything, you know, out of the ordinary that we're doing, and try to figure it out, I guess. I guess what we'll do is we'll start to just comment stuff out and see where we happen. So let's start with commenting basically everything out here, and there we go. And I will comment you out, and on spawn you're not gonna do anything. Now we have to fix these. There we go. Okay. Will this compile? It should compile, because this is basically what the other state machine is doing. There we go. Okay, so let's start here. Let's start this with this function only. And I don't know what to do here actually. Can you just do this? Is that possible? No? Well, let's do... Actually, let's do this. Let's do that. And then this. Alright. Does that do anything? Probably not, because it's only getting this a component out and checking for times up, so there's nothing weird going on there. Alright, now we have normal behavior. Wait, is this even being called? I don't think default behavior is even being called here actually, so I think we're not really doing anything. Maybe we'll go from the other way around. I will enable everything. Well, okay, now everything is enabled. But what we'll do... Maybe it's this switch that's the issue. This is the only thing that's like kind of weird right now. This switch here. Maybe if we change these two pointers, will it work? Maybe. Is that the issue? No. Okay. But I'm looking at this as the prime suspect here. Let's just do... Well, it might be that comparing to pointers doesn't work. I guess. I'll change the notation to this. Yeah, I'll just put it else there, whatever. Okay, is that the issue? It might be. Yeah. Interesting. Okay, so switching on a pointer to a function. I'm not sure if it's just a pointer to a function or if it's just a pointer in general that makes this error happen. Let's try this out. So let's make a number, I guess, here, and we will switch on this, on the pointer to that. Whoops. And we'll say if it's 0, we will, I guess, log out. It's 0. If it's this, it's not 0. Now this would probably maybe be sort of optimized away. Maybe not actually in the debug version though. And then now it's gonna complain that it needs an else, I think, here. Yeah, else, it's else. Okay, what now? Expected. Oh, int to pointer, or pointer from int. Do I need to cast it, or must have a known? Okay. Does not allow 0 address. Can we do... Is there like an int from pointer? +1. And then pointer from int. And that should always... This should have a result, right? Comp time expression. Yeah, the thing is that this I is like okay, let's use something else. Let's use, we could use maybe this entity. Unable to resolve comp time value. Oh, so it's trying to do it like a comp time thing. Why? Okay, I don't know. Maybe this just doesn't work. You know, pointer to something here doesn't work. Can you do this? What would that be? Use of undefined, yeah. What if we do this? Let's just try this without anything there. Okay, that apparently works. Okay, what if we say new state? Like this. Is this enough to make it break? No, so that works. But if we do this, then that should crash or not compile. Yeah. Okay, lesson learned. LLVM does not support, or if there's, you know, Zig produces some, it doesn't handle this case or whatever. But we cannot switch on function pointers. Interesting. I will look for this. Sig switch function pointer. Nope, I don't find anything. Okay. Right. So maybe, well, okay, so then we could go back to this. If we want. Right? Or is that also an issue? No, that compiles. Okay. So let's go back here. And run this and see what these guys are doing now. There we go, it's spawning. It's idle, it's walking around, or jumping perhaps. Yeah, let's look, maybe like the jump. There's the walk. So it is walking around. Also changing direction on the ledge, which it didn't do before. And yeah, the attacks aren't implemented yet, so yeah, but okay, so the walking and idle works, but the jumping doesn't work. Alright. Oops, it's the wrong thing. Okay, but the point was that all of this stuff does work now. So very good. Now I'm just gonna do this, because we can fit this in one line. Okay. And I mean, I guess we could just do sets. No. Set state. Maybe this should be part of set state actually. This should be part of it. And whatever state we're ending up with, we're gonna do these things. So that is not the responsibility of this here. All right. Oh yeah, because we're not, I didn't call the jump function, so we should add these. We should do these, and then the jump we should do jump. The angle is this and strength. Oh, this is like angle adjustment. The jump, it's sort of like a random, I don't know, the angle adjustment is based, yeah, it's based on the direction, and they have an adjustment And then the angle is calculated based on that. Yeah, so we should probably rename this to angle adjustment or something. I don't know. All right. Cool. Now this guy should jump as well. I just think about this set state. This is kind of dangerous maybe, because it's like, okay, but here we're just setting the state. If we have a set state function, we should use it. That's kind of like, you know, normally in programming, if you have a set thing function, you're gonna think that, oh, I'm supposed to use this function. However, here it's basically only for these states. It's not for like the dead state or whatever. So I mean, I guess we could add an if here if we're dead, or have some other stuff, but we're not really doing anything there. So this should probably be renamed to something else, like maybe. But then again, it is sort of supposed to be a generic, also like state transition function, like what is happening in these transitions, which is kind of missing from this system here. It's kind of like, yeah, you have a function. It's very simple for the update functions to have just, you know, this is the function that's being called. But they really should be paired with maybe entering into the state function, but also exiting maybe. So we could really do something like pre-jump or, you know, pre-jump like this. And that could be magically called from the state machine system. So anytime the state is changed, which could be, you know, let's say we extend this functionality a little bit, because the whole point is that it makes this cleaner. It makes it so that this won't be like an ad hoc sort of system every time, because this is really something that we really need to have in most cases, like having some sort of thing that happens on the transition. That is what is going to happen. And maybe it also depends on which transition it is. So you could have a function called like on the state machine. You could also register a function. Let's see. I'm thinking of way too many things here at once. So you could have pre and post stuff that is going to be called whenever the state is first changed to this. So in order to do that, you have to go in here, and let's say we have has state changed is a bool, set this to false or true, depending on you know, the philosophy there. Then we'll have let's say we have an init function that we have the initial state there, and this will return a state machine. Alright, and then we'll have a function called set state new state, and this will, and also self, this will set the state to be no, this will set you to be new state, and then we also set has state change to true. Okay, and let's see. Yeah, and when this happens, we also see. Okay, now the problem is, how do we like get those functions in that case? I'm thinking like, okay, maybe we can register them in some sort of dependency injection container that has those things. Like, yeah, we're registering, but then there's gonna be like a whole bunch of boilerplate. Although we could have this, and then here we're setting has state change to false, and then during this it might be set to true, and then if it's true, then what do we do? Like, what do we do here? Do we have a separate function that is called transition? Oh, that could actually be pretty cool. Like, let's say we have the transition function, which is also a state function. However, no, this is a transition function because we need to know the previous state. So let's say we have yeah, let's say here we have like transition to jump, let's say. I mean, we could call it pre-jump or whatever. Yeah, and this will do this this thing. We will set the end at. We will play the animation. Yeah, now it becomes a function instead. That is way better, I think. Okay, pre-jump. But what is going to happen here is that when we set the state to jump, we also want to set the transition function. And that could be different also based on where we set it. So let's say, let's also let's copy this, have pre-idle. We do the same thing, except we set the animation to idle. This is looping. We are not jumping at this point. The rest should be the same. The idle, we don't really do anything. And then we also have pre-walk. So it's not magic anymore. Well, anymore. It's not magic, though. What we need to do is we need to now register these functions as well. Like when we set the state here. So actually now it's more. It's better if we do this. So we'll move you over here, but we don't call set state. We say the state is going to be jump, and the transition function is now pre-jump. Except we don't set state like this. We say set state to jump. And I guess we could also add the transition function as well. We could just execute the transition function at this point though. So that's the issue now. It's like, okay, we gained maybe something, but then we lost another thing. We lost this common functionality that we don't like. Now we need to sort of, well, okay, we have a common place for the functionality, but now we need to, every time we set jump, we also need to add pre-jump here. Well, maybe these two together could be the jump state, though. I mean, we could just call pre-jump. Yeah, instead of doing this whole thing, we could just call pre-jump. We don't need this. We don't need this entire thing here. We can just call pre-jump. I mean, this one is kind of nice to have, so I'll keep that. But we don't actually need all this crap, right? We just need to call pre-jump here. Well, what would be nice is to add, what you could do is add like the previous, if you need it, you could also have the previous state, so that depending on the previous state, we can do different things. If we enter jump from another state, from walking, maybe the jumping is longer or something like that. If we entered it from idle, maybe the jump is shorter, something like that. So it is still fully possible. So we kind of, you know, now we set the state to jump. This is like a compromise, and I like it. I like this compromise. Yeah, so we're setting this state to walk. Actually, we are setting you to walk, and then we're calling pre-walk. Right. Actually, we don't need to specify the state. The state is already saved in here, so we can look at this state to see the previous state, because we're changing the state after there. Yeah. Okay, so now we don't need this thing. And now I realize you know, it feels a little bit sometimes here that I'm trying like pre-optimizing, but I'm going from one system that was starting to become unwieldy, and so I'm really now just looking for patterns that's not gonna be too difficult to change, maybe you could say. Alright. Okay. That should be fine. I guess this could be called like transition to random state or something like that. I'm not sure. Normal behavior is kind of weird. This could be called like yeah, choose random movement, I guess, or random movement. I don't know. Random movement, it feels like I'm saying something else. Okay, I'm not gonna worry about too much now about the naming and stuff. I'm just gonna keep on going. Okay. Now what we did lose, however, is this common functionality here, which is like, but we could set this default pre-movement. We could just set this to be here. Yeah. So we need entity, we need T. We could also have duration. well. And so now we can call default pre-movement. There we go. Yeah. All right. Saving a little bit. You know, not repeating. Okay. Cool. Yeah. So yeah, that's a little bit of compromise. So I mean, it turns out I'm trying to favor this kind of calling the functions, like compromising, not building in more like system like things here, but utilizing the just functions in this system here. So so yeah. Choose random movement. Yeah. Yes. I don't need to return there. Okay. Unused. Right. So that means we don't really need this. Wait, but we do need it though. No, we don't need it. Okay. So let's remove that. Yeah. So the only thing is now, like, we change the state, we have to remember to, you know, call the pre function before. So we'll see if this pattern holds. Otherwise, it would be nice to have a thing where the risk here is that you forget to call this, but I guess it's easily also, like, when you're testing, you can easily see what the issue is. But I like this pattern here. All right. The only thing we could change is, like, having the pre function and the state function be a unit, and so you could do something like this. You could say walk state is pre-walk and walk. Jump state is pre-jump and jump. And idle state is pre-idle and idle. This feels like we're registering. This feels like very boilerplate, but and then we can say, you know, we can have a set state function, set state, all this crap here. All right, and then oh yeah, and then we need the new state, and now this is a tuple of these kind of functions. So we'll have a type called, I don't know, sn state or something, which is a struct, and it's a tuple where the first, oops, well, it can be a tuple, it can also be a yeah, whatever. Let's make it a tuple, and then we can say transition function or pre function. Well, pre function, that is going to be, it's a little bit different, really. I mean, it could take SM there. Now the issue now is that we have to make them the same. But yeah, let's do that. We'll take this. So we'll have, like, actually, let's just yeah, the pre function pre-function. Is this. Alright, so this first we'll have a pre-function, and then we'll have a state function. Alright, so that is like this was what I'm thinking, like having these as units, and this is all to make it so that we make sure that they are called, you know, that they are actually being called together. And then now we can say that the new state is a state pair thing. And what we're doing is first we're calling the, so first we have the pre-function, and then we have the update function. Okay, so this is the update function, this is the pre-function, and then we're calling the pre-function with registry, entity, and timestamp, and then this will be the, well, then and we'll also change the state to the update function. There we go. So this is this little trick here, or setup. The only boilerplate really is, well, this function could be moved out, so we don't really, this could be generic. We don't really need it to be here. These things could also be moved out to be generic, but this is the only boilerplate really that we're gonna have. So you're setting up these pre-functions, but now we can make sure that we're actually calling these functions, these things together once you have this, because now instead of doing this, what we do is we do set state, and the new state is the walk state. Alright, now this could even be like comp time known, I guess. Yeah, I guess it has to be comp time known. I think. Let's change this to set state, so that it has the actual correct type. Alright, so that's a comp time known thing. Does it have to be comp time? I guess it doesn't really have to be comp time known, maybe. I mean, it's really just a struct of 2 pointers at this point, so no, it doesn't have to be comp time known. Okay, so so we're calling pre first, and then we set the state. So now now we can make sure that we want to set the state to walk here. Is there a better way to do this? I guess what we could do, just so we don't have to, it's like, I don't like passing all this stuff here, because it's like kind of hard to see what you're doing here. Maybe this should be like condensed into like a context, actually. Even T, yeah. This should probably be like condensed into a context. Like, it's so annoying to have this thing every time. So you have like a state machine context. Yeah, that makes sense. That would make it a lot easier to deal with, I think. You're just passing one thing. Yeah. I really like that. Okay, let's do that change right away. So forget about this transition function. We need to have a state machine context, and it's gonna be a struct. We're gonna have the state machine. We're gonna have the registry, entity, and T. And I will make a convenience init function here. So we don't have to spell all this out. Every time. Okay, now this will take a state machine context, and this doesn't even need to be a pointer, so we can just make it, yeah, we don't need it to be a pointer actually, and that's it. That's the function. Alright. And then here we're gonna make a context. So this will be a state machine context with, well, basically things we have in here, and we'll pass context into there. All right, now we need to update some stuff. Right, because it's gonna be so much easier to do all this stuff. Let's start up here. Here, I'm just gonna say context ctx. Wait, let's export that to lib. There we go. And here we can simply pass in context now. I mean, it does kind of lower the reuse of these things, but they are basically just, there are some functions that I actually use now in the other system as well. We'll see, but it's so much easier just to pass this. And I will pass the context here. Well, this is kind of weird. I mean, this doesn't really need other stuff, but are we using that somewhere else? Test monster. If we're only using these within this thing, then there should be no problem just using this context. And it's gonna be so much easier. It's sort of like a monad in Haskell. We have a context, and you know, you're calling these functions that only can be called within this context. It all works out. What you could do. Can you do this? No. Right? That doesn't work. I wish you could. Like this deconstructing based on the field names. That could be cool. Set animation. Can you actually do that? Let's fix all these things first and we'll find out. I mean, I guess, yeah, for these things, I'm just gonna say reg equals to this, registry entity is entity, and t is this, so I don't have to do it for everything. that should be good. On spawning start. So this should take the context only. There we go. This should also be a context. And on spawn as context. This should take context, and this should also take context. Yeah, a lot simpler to do that. And, you know, it's also gonna be like, if you wanna hand over the timestamp or not, it doesn't matter. Now, it's always gonna be available if you need it. We don't need to worry about thing like, yeah, the signature being slightly different or whatever. Now it's all the same. Yeah, all these context now is that. Good afternoon, Maicon. How's it going? I'll do some more refactoring, trying things out. All good. Nice. Nice one, same here. Trying to make a scene to hold all my game objects. Okay, cool. What kind of approach are you taking? Let's see, this context. Is blocked at so the upside of this is that the signatures will be way simpler. It will be way easier to call these functions. You're always gonna know, okay, I'm just passing the context and we have access to these different things. The downside is that they become more coupled to this kind of system. But I don't think it's gonna be that much of an issue, because this state machine concept is pretty easy to actually do. The only thing is the state machine. That's, I guess, the only thing that could be difficult to do. Actually, you could actually remove this and get the state machine out of the registry based on the entity as well. I guess that is possible. That should be fine. I mean, we could just do this. And then this would be get state machine from the entity. Or just this. There we go. the moment I'm using the union enum to make a generic list of objects and checking how the object can make requests to the scene as well, like player to spawn projectiles. Alright. So a tag union to differentiate like the types of objects. And how the objects can make requests to the scene to spawn project. Okay. Nice. Yeah, that should be all that we need. We don't need to get this. There we go. Cool. Yeah, I'm making this a little bit more like a monad-like thing, where every function has like a context that is being passed around, and which you know, it kind of, as in Haskell or other languages that has that, it does force things that are in the monad to be kind of, it's very coupled in the monad. So everything, if you need a function that is in that monad, you have to first have that monad, and then, you know, if you want to get something out, then you have to like deal with that monad in that case. It's basically the same thing here. That, to me, that's mostly what a monad is. It's basically a function with some sort of context. And this is like, okay, yeah, we have these functions with this context, and then but then it can become more a lot more powerful, because you can do a whole bunch of stuff with that. But it is a little bit limiting, because they're not like quote-unquote pure functions anymore. Oh yeah, this one? No, this one is not a context function. That is not what that is. Alright. See what else we have. This, no. Okay, so I think everything in here has been replaced, basically. This one doesn't need a context, so we're not gonna worry about that. There we go, context. Doesn't need it, context. This one, alright, context. There we go. And this one as well. We don't, you know, sometimes the function is like, okay, do we really need to make it into this thing? But I think it's, you know, if we make it into a convention here, it's gonna be easier to get into the pattern once you're in there. Has state ended. So it's basically, the idea is that anytime you're in the context of a state machine, you now have a context that you can pass around, and it gets easier to get at certain things that you want to have. This one is a bit different. This is actually used both outside and in the context, so we do want to change it, but I think for now I'm gonna keep it like this. And once maybe all monsters have been transitioned, we can transition this into that make into state machine context function when all monsters have been converted to state machine style. And jump is, well, actually jump is only used there, so this could actually be a context state function thing. And there we go, easily converted. All right. And once, maybe even, you know, maybe once this machine context has been common enough, we could add more functions here. We could add things that you could do on registry directly onto this function so that we can conveniently call just context.get or something like that. I don't know. We'll see. Let's see. So now here, now we need to change. So let's go first. We'll change this, and instead of all this, we have context. There we go. And is within. This takes a context now and distance. So pretty easily refactored here. This takes a context and walk speed. Yeah. So it's you know. It reduces the noise is what I'm also was looking for. It reduces, you know, have to pass like 4 different parameters every time, like arguments every time. It's just, yeah. Face player, you only need context now. So it's basically, this is kind of like this is typical sort of monad style outside of a language that actually has like monads hiding, because in Haskell monads, they do hide the context, so you don't have to pass the context in every time. But this is kind of like, but then you also define the things in a different way. Here you can actually I guess they could technically be maybe some way of using monads in like a proper monads, so that you do something like this. You have like a return sequence, and instead of calling these functions, you pass them in as arguments like this, and this you pass in as an argument like this, but then that returns a function that calls on context. You know, this is the typical sort of way you would do with monads in that sense. So, but this is kind of like the same thing, but it's limiting in other ways. But now we actually see the context and we pass it around. But now we see the pattern as well. So this is like the pattern of sort of like a monad here that we just pass, but it just means that we're passing around a context that we're dealing with here. All right, and yeah, so that's it. We don't need to do anything more there. The only thing down here that I could think about, we could use the .init function now instead, so we don't need to, so we get a little bit, I guess, easier way of initializing that. Okay, let's go to mossing now and do this one. It's pretty easy to do these things. Now here, yeah, this could just be context. Just passing in context here instead now. This one, yeah, it only needs context. You are a bit different, so you need these things still. And T as well. But easy enough. Default behavior, context. I don't know. So yeah, so it's kind of like I'm trying out, and this is what I mean also by we're testing this out, this new style of handling the state of monster AI, and getting into sort of speed bumps and trying different things, and now we're sort of figuring out stuff along the way. And I believe this should be a nice upgrade, just because there's a lot less noise now. That's one major thing here. There we go. We're just passing in context, and if we need anything else, we can pass that in as well. Okay, ignore all this. This one is also context. Oops. And now we can pass context here instead. Right, so this needs context, and then it also needs duration. But it becomes a lot clearer what part is, you know, the context that is always passed around. You see all this noise over here, and what is the actual data that is needed for this function here. So yeah, that is really nice as well. So now this will be context and just the duration. Set animation is still outside of this system, so we have to pass these things in. Jump should be context. There we go. This one is just context. Same thing here. Let's see, this one is also just context. Idle, pre-walk, walk, and dead. All right. Oh yeah, I'm here. So. Cool. Yeah, that really reduced a lot of stuff, and I think it makes sense to have the a context of the state machine, everything that's needed for the state machine, and we just pass it around as this constantly. Oh, I forgot about this one. Context and random, and this one. And another huge thing is that this context, like we had stuff like t state machine. Maybe t was not needed for some functions, and then we had to remove t or put underscore on it, and it was just a hassle to deal with different things like that. But now, as we put it in a struct, we don't have to specify them all the time, and we don't have to omit something sometimes, and now it's all the same every time. It's much easier to think about. It's much easier to just call a function that needs this context. You just pass the context and that's it. All right, now back to this part. So the question, if this pattern, we're gonna do this. So what was the thing that I was thinking about here? Oh yeah, so this could just be the context now. So actually, this is just a this is just another state function. So the idea here is that when we set the state to some other state function, state update function, since this update function, this is like the function that gets called every frame. So it's like we don't know what the problem is, that how we're gonna do the initial like pre when this state was first, like, what I'm trying to say is that when you transition from a state to another state, we also want some sort of event function, or some sort of functionality that only triggers once on the like at the time of transition. And so we have these pre-functions. Pre-walk is happening one time as we enter the walk transition, and what that does is setting the walk animation, and we're also choosing like a random direction and stuff like that. So we want to do something as we enter the walk state. But now the state is this is sort of encapsulated in two functions now. So we have the transition function, and we also have the actual update function. So we have two functions now. Now the question is if we want to have this as a sort of as a pattern. And I believe so, because it's a very common thing to do. Like when we want to transition from another state to this state, we call this function, and we can even see what previous state it is by looking at the state here. Wait, state machine and state. So this state is the previous state at this point, and so we can look at what the previous state is, and if we're transitioning into walk from a jump, maybe we do some I don't know, a little landing thing, like a little glide, I don't know. If we're transitioning from idle, maybe it's like a slower start or something like that, if we're transitioning from idle to jump, maybe we'll do like a short jump. If you're transitioning from walk to jump, maybe we'll do a long jump, something like that. So it's like you can do that if you want to with this system here. So that's what I'm thinking, is that this would be a nice pattern to have, and this thing could be moved out into a generic place. This function is also generic. This can just be moved out, and then you're gonna use this function to set the state. If you have this sort of setup here instead, you could even define these things like this. You could even have, like, let's say we have a you can even do this. Let's say we have a jump state. This is a SM state, and so this is actually incredible. We can we can have well, actually no, because okay, yeah, well, actually, if this is let's say this is a function that takes a struct, and then we have like pre, okay, am I cooking here or not? And then we have a update. So this is sort of now we can make these follow a interface. Hey Doomwretch, how's it going? Welcome. Okay, and then you don't have to have a pre-function. You can omit this if you want. But we can make the states using this instead. So it's no longer just a function. It's a collection of functions. And you can have a pre-function, and you can have an update function. It would be incredibly nice if if you could define functions on the fly without having to type out a struct container and then accessing the function on the container, because you could do this. Yeah, so then jump, this will become an actual sort of state here that we can then call set state with. So it's gonna be a little bit more, not as pure and nice as it was before, but now we can include the concept of like transition things. And then let's see. Yeah, so now this is no longer just a struct, this is a function. Let's make it public just to have it there. And then we have the, well, yeah, the state, I guess. State functions. And this would return some sort of type. I mean, I guess we don't really need this. We don't need that. We can just set it to a struct directly. Yeah. We just set it to a struct and then we just follow this convention. And if you're forgetting, if you're saying something wrong here, then that's going to be a compiler error. Because in set state, we can check if, you know, if you have a function that is not part of the thing, it could be a compiler error. Or, yeah, I don't know. If you could check if it's valid or not here. In the set state function. So you could call this, then you can sort of validate the functions. But now this is no longer a, this is going to be a, well, this is going to be a type, I guess. And new state.pre. So what we do is we say if pre has a declaration, or I mean if new state has declaration pre, we call it with the context. There we go. And we need to update the thing there, so we need to set the update function there. There we go. Okay. Yeah. And because now, okay, the whole point of this is that, well, now we don't need you, so we don't need a separate definition step either, which is really nice. That was really what I wanted to get away there, like less boilerplate. And we can get rid of this, and now idle is also a thing there. And you could even do, like, let's say that this is any type, maybe. You could check, okay, is it a type or is it a function? If it's a function, then we just set the update function directly. Or if it's a type, then we do this thing. So this could actually be any type. And then we'll switch on the type info of type of new state. And if it's a type, I think it's this. Then we do this part here. Then we know it's a type, so we'll do that. If it's a function, we will just set this to this function there. Otherwise, this is a compiler error, and we will say invalid state type. Yeah, type of. Wait, type name, type of state. Okay. So yeah, that enables us to, we don't have to create this structure, but this defines one state. but we could also just have, you know, where's that, the dead state. We could just have this as a function as well, so we can pick and choose here. Yeah, I really like this actually. It becomes a little bit, you know, now we have sort of two ways of doing one thing, but it does provide a way. I wish there was a way to maybe create the state in some other way, like have a tagged union. But the problem is that you have to define the problem is defining the function is so clunky in Zig. So this is like the easiest way that I can think of right here. Okay, this is update, this is tree, and walk also has that. Update tree. Okay. Yes. Now instead of doing this, we call set state with jump. Idle and walk. Okay, cool. And this one, yeah, nice. So now it's like, okay, we call set state and walk. Now we make sure that we don't forget to call pre-walk at this point. So it's all in the spirit of safety, or yeah, whatever. Don't forget to call this function. But now it's like in a system. Now it's encapsulated in some sort of system here. And we could add more safety rails where we say that, oh yeah, if you misspell this, then we say like I don't know, unknown function or something like that. I don't know. We could have a validate state function. No, we don't need context. State is added type, and then we will switch on type info, type of state, and basically we'll do this here. I actually started to do a weird thing, type assembler. Okay, I'm not gonna explain what I'm trying to do here, but no, wait, this is actually the wrong place. Where did I have that validate function thing? Oh, state machine. Oh, I see. Let's actually make this public here. This is a really nice thing. You can validate a function. You have the container of the function, the name of the function, the expected parameter types, and also the expected return type. So you can sort of validate that the function has the correct signature, basically, and that it exists on the struct as well. So we can say here, for example, if it is a function, well, okay, now we don't have a container, I guess. It's just a pointer. Okay. We need a separate thing here. We need a, okay. Validate function. Actually, let's do this. Let's rename this to instruct. And then here we're gonna say validate function. And then we don't have this. We have like a, I guess we could pass in like the function type info maybe. No, we'll send in the type. Yeah, that's better. And then I guess we have like a weird error thing. Well, I guess it makes sense because this is the inside the state machine anyway. Has declaration, so we don't need to worry about that. The function is type of field. No, it's not. It's this. There we go. Is that the only thing we need to do there? Yeah, so basically here we can replace this with validate function. Function expected params term type. There we go. Oh yeah, that okay. Well, right. I guess we'll pass in an error header as well. Sure, why not? Type as well, now wait, here. So here we'll validate. We'll say yeah, validate function. We don't really have that. I'm just gonna import this for now. This is gonna be in the same. I mean, let's just put this in the same function. Let's move these two out here somewhere. Actually, this could be on the context itself. Yeah, so this is like self. Yeah. Okay, now this would be validate function. Function type is type of state. Parameters is gonna be. I mean, actually, we could just say if it's equal to the state function, but I mean, yeah. Yeah, this is just going to be state machine context, and the return type is void, and this one is, I don't know, let's just have an empty thing there. Yes. Okay. Now, if it's a type, we're going to validate that this function is in this struct here. This is the type, and we want to validate it, that it has an update function. I'm just going to do this for convenience here. Yeah, and if it has a declaration pre, we also want to validate that. Otherwise, I think we want to inline for the fields of new state and if the name is equal to pre, we continue, or if it's equal to update. Otherwise, we will have a compiler error, because now we don't, this is like an invalid function. So unknown function field.name. So let's do error header, something like this. Yeah. All right. Okay, so now we're validating that, okay, are you adhering to this? Anything that is not pre or update, we're gonna compiler error. If we have a pre, we validate that it's the correct you know, signature here. If we have an update, we also validate that. If it's a function, then we validate that it's the correct signature. If it's not a type or a function, then it's an invalid type. So now we have a compiler validation of this thing, so you don't accidentally do something stupid here. Nice. All right. Now, what now? Set state. This is actually, now we can say context.setState. Yeah, it's even more clean now, I think. That's actually really, really nice. Okay. All right. Yeah, and as I said, if walk needs to know, if this pre needs to know what state you transition from, you can have like if state machine state is equal to. Now this becomes a little bit more tricky, I guess. If you want to check if it, well, if you want to check if it's the idle, you have to do this now. But you know, it's not that tricky. And you know for sure it's gonna be called update. Okay, so then you can do something, or if it's jump or whatever. Okay, cool. So it's very, very keeping the sort of thing there. And you can also pass this type of function if you want to set state. So now whenever you set the state, you should always use then set state function instead of setting the state manually. All right, which is fine. Now setting state manually is more difficult. So here we can do set state to dead, and that should also work. All right, let's see. U ends at, yes, fine. Yes, there we go. So this could also be, you know, we could make a function, like convenience function on get, like on the context to get. Yeah, I really like that actually. So you don't have to you know, do this. What you could do instead is context.get, because we already have the entity on the context. So you could do .get this to get the thing. That's a way more convenient, and it's such a common thing. You want to get something for the current entity. contain t type, and I guess we can say keep it to context here. I usually say self, and we can also add like try get, but this is really just registry get t on entity, and we can also add try get, whoops, which is an optional. Oh yeah, dot get, try get. There we go. And now we can do that. And we even get, now I think even we get sort of the correct type out as well, because for some reason the LSP right now doesn't really know what this is. So whenever you have a result of this, it doesn't know. So now that kind of fixes that issue as well. Before I had, you know, I got an unknown back, so you lost a lot of information from the LSP there. Okay, nice. Let's go over here. Now we can do update here as well. So now we say context set state to walk. Oh yeah, and this is like the pre-walk thing, but whatever. We don't always have to adhere to the convention here. And this one we can say this instead. Awesome. And now we get the type here as well. Cool. All right. This one is not used. Here we have to say set state. It's better to do these things now before we have like a huge amount of places to update this on. We also have this guy, a lot easier here. Set state. There we go. Okay, what are we missing now? Monster utils 38. Oh yeah, so now we can do set state spawning. There we go. 251. Oh. Context. Oh, so we don't even need this now, I think. Cool. 311. Places I forgot to do these things. Hopefully this will be nice. It's nice to do this kind of trial thing and having in mind that, okay, this might not work out, but I feel like we're on a nice path here. And yes. Okay, this requires a context now. So, okay, this is one of the places where one of the few functions that, yeah, did not really work out here. But I think what we'll do for now, we'll do a temporary fix for this. We'll do like when we create the state machine, if the state machine doesn't exist because the monster hasn't been like converted yet to the new system, where is it here? We'll do a try get, and this is like an optional, and then we will do set state. We simply say no. state machine. And this is a pointer. Yes. Okay, and now we can easily fix that later. Right, because now if we go back to where the issue was over here, we can do state machine context init and we can remove these now, I think. Yeah. Alright, so then that works. We can use the context outside of the state machine as well now. Okay, same thing here. Okay, what's the issue here? Oh, you wait. No, you don't need T. There we go. Okay, state machine 106. Expected type monster. Wait. Oh yeah, sorry, these are pointers, that's right. No field remember, no field remember function name state in oh, wait. Oh yeah, because it's okay, yeah. There we go. Nullable there. Okay, now it takes longer, so it's a sign that it actually compiles. There we go. All right, let's check it out if it works. Okay, we got a spawn, we got some walking around. Kind of weird. Okay, idle, got a jump. That was kind of weak jump. Why is it not like moving? Okay, but you know, that doesn't really matter that much. The point is that the system does work. Very cool. All right. Well, the question remains if it's gonna be nice in the long run here. But yeah, very nice. Okay. And you know, this could even be like, okay, what? Let's say you don't want to run the pre function. Well, in that case, you can just set the state to update directly, and then you won't run the pre function as well. So we can even also add like a post function if we want. And if we have a post function, then the set state could see, okay, we got a post function. So let's call post function on the previous state. Except we don't have that on the previous state. That's the issue. We cannot save the struct as a state. That's also the issue here. The only thing we're saving as a state is actually the update function. So never mind. Yeah, that's too bad actually. But okay, so we can't really have a post function, I guess. Well, actually we can. If we add a new pointer here, we could have a post function that we save here, depending on the state that you put in. That's true. I mean, I don't really have a use for it right now, but I'm just looking at the possibilities of what you could do with this system here. So that is yeah, that is possible to implement if it's needed. If you need to sort of do something on an exit of a transition as well. Okay. Really nice. I really like this. Okay, so now we need to do the attack. Maybe we'll do the aggro first. So we got the aggro here. Yeah, I probably should eat something soon here, so I'll probably run maybe half an hour or something. I'll tell you what, maybe I'll go as far as I can on this. Hopefully get this done now. The whole point of this is also to make it so it's sort of easier to implement this this kind of state function. This is one of the more complex monsters as well, so it makes sense that it's not gonna fit in one screen. But let's see. So we have like a should attack. So this is basically we're checking each. This is basically called in each like update function that checks. Okay, should we do an attack? But where's the aggro stuff? So yeah, the aggro is actually that's done outside of this. The only difference basically is that we're changing the speed. I think we also turn towards the player as much as we can. So we could re-implement it. Maybe it's easier to re-implement that here. Now aggro, maybe it's not really a state. Maybe it's more like a flag thing. You know? Because otherwise all of these other states are gonna have to have an aggro version, or maybe it's just a walk version that is different. Well, actually, it's gonna be a bit different, I think. Default pre-movement. I think we're gonna have a different thing here. We're gonna have a aggro pre-movement, and then we're gonna set the direction to face the player. Oops, and you face the player. Right. This is probably gonna be sort of the same here. Okay. What we're also gonna do, choose random movement. So this should be sort of the same thing. However, the problem is that now these guys always use this function and not this function. So maybe we do need aggro versions of all of these. Or we could maybe set the state with some data passed with it, maybe. I mean, the easiest way to fix it also is like, okay, let's not... I was trying to think about, okay, how can we incorporate this into the state system in a statey way? But we could also have is hunting player as a bool that is on this monster, because that's basically very possible to just have is hunting player, and this is a bool and it's false from the start, right? And then we can just check that. We can have a function called is hunting player context bool return context get cleared is hunting player, And then let's see. The walk speed. Okay, we could have a transitional state that is like aggro, perhaps, and we'll set. No, we'll do default. No, choose random movement. But then we also, this is a transitional thing, so we will get the monster and we'll set the walk speed to hunting walk speed. Okay, and then we choose random. So now we're doing that, and we should also set is hunting players true. Okay, now we have the means to enter, or now we have the transition into aggro. So we set this state, so we're walking faster and we're hunting the player, and then we go back to our movement thing. However, maybe we should have a separate for that. The problem is we have the default behavior here. So I think this should actually incorporate this. We should have like idle should maybe not be part of this if it's hunting the player. I mean, I don't think it was actually part of the original thing, though. Maybe we'll actually have an if here, or this function could have an if as well. We can have an if here that is like choose random movements. Yeah, this is the like we're choosing a random the next state to go into. But if we're aggroed, we don't want to do idle. We just want to do jump or walk. The attack is like a reactive thing, so that is going to be not at this point, like when this has ended. It's going to be more when you're close enough to the player. So I'm going to do if. So I'm going to get the monster. Whoops. What the hell? Okay. I don't know what happened there. Okay, let's see. Yeah, this is that, and then if we are hunting the player, then we do something else. So this is the normal thing, and otherwise we have a different set of things. We don't do idle, we just do jump and walk. Alright, cool. So I think this is a nice way of using this. This is basically, you know, instead of duplicating all the states and having a different function for this in order to have like an aggro state, we instead have just a bool that we check and that slightly changes the behavior in certain circumstances. So this could be kept the same, that's fine. And we also have like this could be baked in here. So we could also say if we could get monster here as well and say if we are hunting the player, we do something else, we do this normal thing. So if we're hunting, then we do face player. Yeah, and then we don't need this separate function. There we go. So if we're hunting, we're facing the player and you know, doing that. If we are not, then we're moving as we did before, randomly there. Yes, and then we don't need to change any of these as well. They still use the default pre-movement there. Yeah. Cool. Now what we need to do is we need to, oh yeah, I could have called this instead, I guess, is hunting player. That would be maybe better. Yeah, a little bit less. No, it's hunting player. There we go. Okay. Now, what now? Let me move you up here, actually. Makes more sense. And actually, this is also nice, like on spawn, we have a choice of, do we want to immediately start walking? Do we want always on spawn to be idle? Or do we want something else? So that's interesting as well. I guess we could always do idle. We can also do just a normal choose random movement thing, so we don't really know what it's gonna do. But let's do this for now. Okay, so what is missing here? We need to actually enter the aggro mode somehow. So that would require some things here. Should attack. Or the aggro mode, no. What's that? I think that's like a global, that was like a global sort of aggro attack distance. Here we go. Can aggro on distance equal to this? Okay, so we're basically just doing this to check if we are going to enter the aggro state. And so if we're translating this to this, then we should include it in the default behavior. So we should just say if is within distance to player, and then we have like the aggro, whoops, aggro distance or something. Then we say set state to aggro. So we transition into the aggro state. We also do else if here as well. Well, okay. I guess we have to check also if we're already aggroed. Let's make this into should aggro. If we should aggro, we set the state to aggro. Otherwise, we do something else. Okay. So now we need a should aggro. Also, none of these actually need to be public, so, but whatever. No, you return a bool. Okay, so return if we're not hunting the player already, and if we are within distance to player, aggro distance. Okay, and then we need to define this, which is 100. There we go. Right, so we should, if we should aggro, we set the state to aggro. Otherwise, okay, let's, I guess we can, I think it's gonna now keep this maybe, well, no, like this, yeah. Now it's gonna keep this formatting here. So it's the default behavior is like, okay, are we dead? Set the state to dead. Actually, we should just return at that point. Are we damaged? We apply some knockback. If we should aggro, we set the state to aggro. Otherwise, we're looking for if we need to update our state to something else, and we do a random thing. Okay, nice. And then let's see. What else do we need to do? This is probably easy enough to do, just do this. Yeah, we enter the aggro state. Then we have hunting players, true. Everything should just align here. If it's hunting the player, it's gonna face the player and start moving towards the player. The only thing missing now is like the actual attacks. So let's see if this compiles. Yes, great. Awesome. That was like one of the few times where it actually compiles without giving me issues after doing a bunch of updates there. All right, let's see. There we go. Well, okay, it's not really... Oh, I see. Okay, we need to tweak this a little bit. So the default walking, it does work. It does start to, you know, follow me around here. And it's going into idle, and then it's walking around. If I go close enough, it's gonna start to... Oh, okay. I think I know what's going on with the jumping, actually. Maybe. We'll see. But the thing about the walking here, the default walking is detecting that there's a ledge here, and then it stops. So, yeah, and turns around. So that is... that's what's happening there. So we need to tweak that a little bit. So this is a good exercise now in like, okay, the default walking doesn't suffice here. We should tweak it a little bit and add a version that does not include ledges. So maybe we could add an options here that says that it ignores ledges, because that will work. So we can just do an if, and then we can remove that. This, however, is both for ledge or block. So yeah, maybe we could split it up. Actually, yeah, I think for this monster, we actually only need to worry about, we don't really need to call this function actually. So what I'm gonna do is I'm gonna add an options, default walk or walk options maybe. And we're gonna do, you know, turn around. And we'll set this to true to start with there. And then here we can simply add, if we have this, we should call this. There we go. And then it's also even, you know, dynamic, so you can even, you know, pass in different options if you have a different thing there. Okay, anyway, now the downside is that we have to pass this in everywhere we are using this function. But right now we're not doing it in, we're only doing it in like 3 different places, so it's fine. And here, wait, no, here. Oh, we're doing it here as well. Okay, here you can see also an example where I'm using, I actually have an aggro state and a walk state. However, this guy only has 2 states, so it's not really a huge issue. It's the test monster anyway, so. But let's see. Now this guy won't turn around, or in these cases. So yeah, let's just add that, and that should be good. And let's test this now. There we go. Now he's following me around. Doesn't care about the ledges and stuff. And can you jump up there? This could also be, you know, now I can even see like a more easy way to implement better AI such that jumping over this ledge, because now we can sort of more easily see, okay, where in the state could I update this? It's so easy to actually update this now, in contrast to the old system, because now I can just go into the state machine. I can see, okay, when we're walking and we're hitting this wall, or we want to choose another movement or something, and we can see that, okay, we're blocked. Or let's say we are walking and we're detecting that we're blocked. Okay, then do a jump. Go to the jump thing. Now they're not able to actually jump up here. So yeah, but that's another issue. But I could just see how much easier it is to actually go in and actually do something like that. And it might be bias here because I'm more used to this now than the other system, because I'm currently sort of implementing it. But yeah, let's figure that out here. I'm just gonna refill my coffee. I'll be right back. And we'll try to implement the attacks now. I would have to fix the jumping issue as well. But yeah, BRB. Okay. Right, and then when we're done, we can clean up the original struct here a little bit. And perhaps even the... Yeah, I mean, I feel so good about this. I'm really excited to just get rid of the old system entirely and get this rolling in this kind of way. I can really see the benefits of doing it like this. All right, so let's get the attack thing here. So the attack is like a reactive way to change the state, which means it's gonna happen in the update, which means it should be just added here, which is like the default behavior is being called in the update function for every update that we have. So this is a really nice pattern to have, like a default update function that is called from every update function. And it's like minimal boilerplate that you have to call this function. And it also leaves the option to not call it if you actually need to have some other state update function there. So, and you don't want to run this default behavior. So let's see now. Okay. We want to do something here. So if we should aggro, so we should probably have like attack as well here. Now it could probably be after aggro. Like once we're attacking, we should also do the aggro transition as well if we haven't yet. So I'm thinking I should probably check if we're aggroing first and then check if we should attack. This goes into random movement, so it goes into like the normal sort of behavior here. But then that will sort of trigger an attack again, because we're gonna go into this else here. Else, if I'm just gonna say should attack, and if we should attack, then we transition into an attack. But we are going to choose an attack based on this. Now the previous system actually had a quite, I think, a pretty nice way of doing this. Should attack actually determined the type of attack as well. So for example, we have, when you do a range attack, let's say the player is far away from the enemy, we want to do a ranged attack, but if you're close, we want to do a melee attack. But if you're somewhere in between, we don't want to attack. So should attack is like, it's not only checking, oh, is the player inside this distance or whatever, it's checking what type of attack we should actually do. And depending on the type of attack, we should do different things. So before, should attack actually got you an attack type out, and then we could switch on, we can switch on this attack type, and we can now gonna look a bit weird here maybe, but we can switch on that. Hopefully this else is not connected to the switch now. I know that for loops have else's, but I don't know. I don't think switch has. And then we can say, okay, if it's a throw, then we set the state to throw attack or something like that. Set state to throw. If it's something else, you know, I mean, really, we could probably maybe get... The problem is, this state is now no longer... I don't think it's like possible to pass this, like store this in a variable or something. Since it could be a type. I think what's gonna happen is... Because what I was thinking is, let's say this is a state that we need to go into. Well, we could actually just say, okay, should attack actually calls set state to that attack directly. We could do that, actually. So we could say, instead of should attack, we could say attack if I don't know, if you know, I don't know what to call this. It's like it's the function is gonna check if we should attack, and if we should attack, then it's gonna execute the attack as well. So it's like a conditional execution of the attack. Attack if attack if should attack. What would this function be called? Attack if able sounds, because it's gonna be able to attack even though the player is not there. player needs to be there as well. Attack if valid. Attack if... I don't... This is very... Why can't I think of the right word? Applicable, maybe. Attack if applicable. Okay. Attack if applicable, and if we're attacking, then we do that. We don't do anything. There we go. Yeah, it kept the format. Okay, maybe it's because we don't have anything there. Attack if applicable. Okay, cool. Choose random movement, random pre-movement. Let's have it here, like attack if applicable. And yeah, and here we're just checking. I'm gonna do this to see what formatting we're getting here. We're getting this format, of course we are. I would like if it kept this format. Yeah, it's not gonna budge. Yeah. I don't like that. How does that work? Okay. That is kept here for formatting reasons. That's a sore eye there. Or yeah. Okay. Or whatever. I don't know what to call it. A thorn in the eye. Okay, whatever. Attack if applicable. So what do we do here? So what we do is we check for different things. So we should go down to should attack here, and we can basically copy this, go back up here, copy it in. Now the distance is the distance to player, so we're gonna replace this with mu is within distance to player, and the distance is that convenience function there. If we are, then we calculate some random weird things, and we should really use this thing. I mean, yeah, no, let's not worry about this. All right, if it's less than 0.5, we do high or low. So this is the type of attack that we're doing, and yeah, we need a way to execute the attacks as well, which we don't really have right now. But let's keep it like this for now. And then here is like if we're hunting the player, and the distance is this. So if we're not hunting, then we don't throw rocks, basically. Yeah. And so we have to check is hunting player, and if so now we need to check if the is the distance to the player in a range here. Whoops. So we need like is range is distance to player within range, and then min distance, max distance. So we get the distance to the player. Let's actually just make a convenience function for that. Get distance to player. And we will just return this. All right. A lot simpler there. And now we check if distance to player is less than max, and let's do it like this. Min should be less than or equal to distance to player, and then distance to player should be also less than or equal to max distance. All right. No, not clamp. Range. I don't know if there was like a function for this. It's very simple check. Between, within. I don't know. No, maybe not. All right. So yeah. Is distance? Let's rename this. Is distance to player within or less than? Up here. Okay. All right. And oh, I see. Range attack, distance threshold, no attack. Okay, now that makes sense. I was like, what the hell does this mean? This means the max ranged attack, max distance, and this is ranged attack, min distance. All right. So we have to check is player distance within range. Min distance is range min distance. Max is range max distance. And then we also check the cooldown as well. Right. The cooldown. So the cooldown is interesting. The cooldown should probably, that should be like a separate, that should be like a state stored here. It's already stored here. So we should just check that. And this is gonna be like get, yeah, that's easy enough. So this is basically should melee attack is equal to this, or should throw attack is equal to this thing. I guess this could be called ranged attack, making it more how would you call it? I guess generic. Maybe. I don't know if that's good or bad. Okay. well, now we have the conditions actually here. Let's see if yeah, we need to implement the actual attacks now. They should be states. So this is the first time I'm implementing attacks in this new system. So let's figure it out. But now we have a way to determine the type of attack and if we should attack or not. And we're not gonna return anything here. I'm just gonna do this, and I'm gonna return true. And I'm also gonna do this and return true, and here return false. So that means that we return false if we didn't attack. If we didn't initiate attack, we return true if we did initiate an attack. There we go. So yeah, and you should return a bool here. There we go. T is on context. Okay. I don't really like that this may, like, when you have a bunch of ants, like, it looks so crowded here, but whatever. I'm gonna have to live with that. Okay. I really like when you do stuff like this and everything seems to fall into place. Okay, but now we need to figure out the attack. So let's start with these easy ones, like the melee attacks. They are pretty simple. It's just setting an animation, executing the attack, waiting a bunch, and then do something else. So let's do that. Execute attack. I mean, we could just copy this and figure it out from there. We could make separate functions for those attacks. So we could make a melee attack. Let's do melee attack, throw attack. Let's not worry about this. Throw. Move this into there. That's the throw attack. Alright, and here's the... Now this is like... Oh, this is both high and low. So we'll move this there. Oops. No, that should be... No. Okay, there we go. Alright. Okay, so this is like executing the melee attack. We need the context. No. We also need if it's gonna be high or low. So let's just do attack type is enum high or low. Okay, that should be fine. Now we can actually take this back and we can do melee attack high and melee attack low. Alright. We can also, you know, you could also do like melee attack context, wrap this into the function call, like do this. That's also, you know, what you could do, I guess.
fine. Yeah, so that's pretty simple there. Let's see, we're facing the player, it looks like here, which we should already be doing. I'm gonna remove this for now. Let me just think about that for a second here. I mean, it is good that we make sure that we're actually facing the player. We could just copy this and put that there. I'm just gonna figure this out. So we're attacking. So it could be that we ended a movement. The player is now jumped over maybe. So if we do an attack, we should turn around towards the player and do the attack and not do something else. So we should actually face the player here. Alright. Now the attack animation, attack type is high, then we do, so this should all be fine. We can just do this to fix these calls. There we go. Alright, and now we have this part. So we don't really have this state anymore. What we do want to do is we want to spawn an attack. Now this is what's going to be slightly different about the attack state, or transition into an attack state, is we actually want to spawn a attack entity at this point. So how this works, how I adapted this here is we have some sort of attack. So we have create attack somewhere, and this is basically only in one place. But what we can do is we can copy this, go back here, put this over here. We don't need to call set state. What we need to do is I guess this could be called default damage or something like that. Put this down there. Hitbox. Yeah, we should be able to get the hitbox somehow. Target is the player. Hurts at should be this. T plus hurts at. Destroy at is gonna be T plus hurts at plus hurt duration. There we go. And then we have attack duration, which we don't really care about, so we can just remove that. That's just a playing out the animation. But it is, well, actually we do care about it, because it is gonna be the duration of the state. So we actually do want to say set state ends at, and then it's going to be T plus attack duration. Yeah. Okay. And then it's going to transition into something else. Alright, so that is the transition into the melee attack. What's also going to happen is we need to actually change the state as well to the melee attack. So actually the melee attack is actually now this is the pre-function to melee attack. So we should have a melee attack state, and this fits very nicely into this pattern there. So now we actually don't call this function. Instead we set the state to melee attack. And so we also have a function called update. I guess this is public. And I don't know if this has to be public, by the way, because they are I don't know, we're accessing the type, and so they should exist on the type. And then I don't know, maybe they, if you can have a pointer to a private function, I don't know. Anyway, it doesn't really matter that much. So we have the update function. This should be a thing like this. Oh, actually, this doesn't really work because this is like attack. We need to know the attack type. Yeah. Okay, we could have this. We could have a support function here. This is fine. Execute melee attack. We need a context and we need attack type. So we just set the state. Wait, but how would we? No, this still doesn't work because we need to do these things with the knowledge of the type of attack. Unless we, I mean, we could store the attack type. I guess we can store the attack type here. And then we just use that as state that we can grab and use that. That should be fine. It feels like a scenario where we could do that. Because this is, we can't pass. It's either that or we make some kind of mechanism where we can pass in state here. I mean, I guess we could actually make this into a function that returns a type that returns this as a struct, and then we configure it with an attack type. I mean, this is actually very possible. We execute a melee attack. Yeah, why not? And yeah, now we don't need this support function. Yeah, I mean, this works just as well. Yeah, this is actually really nice. So yeah, this works out. We don't call this with context. What we do is instead we do set state, and we call melee attack without the context, but then we have the attack type. No, like that, right? Yeah. Awesome. Okay, and now we also need the update function. So the update function, I mean, we're basically not really doing anything. We're doing like the default, I guess the default behavior. Except we're sort of in a, it's sort of like the default behavior, but I think we should only do these things. Oh, and also we should check if the state is ended. So I mean, I guess we do these things. If we set the state to aggro though, we don't really want to do that. We should only do it if we're not attacking actually. But then I guess should aggro, like if we're not already, wait, but this is not really a okay. You know what? This shouldn't be a separate state thing. We should just call aggro. If we should aggro, then we call aggro. And we don't really have an else here. This just sets a bunch of states. This just up. We don't do this. Yeah. So now aggro just sets these things. So it's basically turning the aggro mode on, right? So we don't really have to worry about that. So now we can just call default behavior because still we want to check if we're dead and set the state to dead in that case. So that quits out of the attack. That should be good. We should still be knocked back, I think. I mean, that could be something that is sort of configurable as well. But let's do that. Should aggro is fine. Attack if applicable. Now this should actually check if we are already attacking. So now we don't really have an attack state that we can check for. So that is the difference now. We don't really know if what the state is at this point. We can't. This is the problem though. I mean, I guess we could have a function that says like is attacking, and then it's gonna check against all the different attack states, but that's gonna be inconvenient. We could also have like a flag on the monster that says if we're attacking or not. I guess that could also work. Because then we can just check here, like we could just check on this, are we attacking, then we quit out of that. But then we have to manage that state. And so when we transition out of attacking, we should set that state to. So then it would be nice to have a post thing. Yeah. Actually. Yeah. Alright. So we should have like a default attack pre and pre-default or default pre-attack and default post-attack. Yeah. Yes, I think so. Okay. Okay. So then we do this. We say is attacking. Alright. And we will at our attack stuff, we will say default pre-attack. Whoops. And we will say is attacking, so we will get you. Now why am I not getting like the type out? I don't really understand why it doesn't understand what the result is. I have to do this, then it understands. Okay, that's a bug, I would say. Anyway, is attacking is true, and then we have a default post attack. Is attacking is false. But now we need to sort of well, we need to call default pre-attack here, and we also need to provide a post function down here, presumably default post attack. Right, so we have pre, during, and post. Okay, cool. So now we have post. Now we need to actually implement that functionality. So let's go back to state machine, and luckily it's pretty easily extendable here. So let's see, validate, wait, where is the validate state? Here we go. Let's also add a post, and we will also do this. All right. Yeah. And then oh yeah, it's the set state function. That's right. Here we go. Set state. Let's see if yeah. So if we have a type, then we're checking if we have pre. We do that. Okay, and now, as I said before, how we deal with the post function is we have to actually store the post function here in order to know, because we can't get the information based on this pointer because we don't know which struct it came from, and we can't store a struct in here, I don't think, because it's a comp time known thing, so we can't store it in this weird like thing. So this is now, it's a nullable, and we set it to null, so that's fine. Okay. Okay. So state machine, yes. Update, fine. Post, where are we here? So we are over here. So we can then here say if we have a post. Well, first of all, we want to say if we have a post function in our new state, we actually want to update our post to that function. Okay. Also, are we calling this anywhere? Oh, we're not actually calling this function. We should call it here. So we should call the function validate state on new state, because it's a comp time and a type thing. I wonder how many compilers we will get from that. Okay, but that will help us keep the new state in the correct format and stuff. Okay, so if we have a post in our new state, we update our current post with that. However, we also want to here check if we have a post in our previous, because now we're ending the previous state and we're entering a new state. So we want to call the post function, and so we just call this on that. There we are. Okay, cool, and that's it. That was pretty simple. And now we have support for post calls as well. And if we go down here now to the where's the attack here, the pre-attack and the post attack and the pre-attack, and those are gonna set is attacking true, is attacking false, respectively. So now we know that we are attacking or not, and so here we can actually say if we are currently attacking, then we should just return false and not do anything. So now even if attack update function calls this, we won't enter a new attack immediately, because this one checks if we are currently attacking or not. All right. Trying to keep things. Wait, no, this is okay. There we go. There we go. Anything else? Okay. So yeah, so that is the melee attack, right? Most of the things are happening in the setup here, where we're actually setting it up, and then during update we don't really do much different. Okay. Yep. I mean, we could let's see. Now, probably all of this could probably be sort of generalized as well, and maybe we have a few things that need to be checked, like what animation do you want to do? Is it going to be looping? What's the timing of things? And then we should be able to create the attack here. The attack type, we don't actually have an attack type. This, what do we actually use this for actually? Let's go to the attack system. Do we use the attack type for anything here? Or is it just a no for other systems? So this could actually now be a nullable or optional. Like a transitional thing, we can set it to optional, and where it's, you know, where we know that we have it, we can enforce it. Where we don't need it, like here, we don't really want to set it, so let's set it to null to begin with, and we're gonna just remove this here. I don't really, yeah, the attack system doesn't need it. It's just the, I think, yeah, it's a monster system, the old monster system that needs it. All right. Yes, attack duration. We know that we have the thing there, so that should be fine. All right. Yeah. Okay. Most of these things probably gonna be in the throw attack as well. This is the same thing, so this is gonna be face player. We also have default pre-attack. All right, and I mean we can even put face player in default pre-attack actually, so we don't need to call it multiple times. There we go. Anything to reduce repeated things. And then we just set the animation, fine. We do need context. Now this is the similar thing. This is a throw attack, but this could actually be just a struct now, where this is the pre function, and we have a update function. I suppose these are public. And then we have post. Here we go. Pre, I guess you need to be public, I don't know. Yeah, and this should be the same here as well. Okay, throw attack, you don't need to be a function, but now you're a perfectly valid state that we can set to. Okay, default pre-attack, we are playing the throw animation, we're getting the duration, we are setting the state here, and we have a cooldown as well. So yeah, this is, now we can say context get cleat and say throw cooldown is equal to this. Alright, so that's the appropriate difference there, and we also do the create attack thing. So let's copy that, and then you are that. The damage, we don't have it, but it's always 1 at this point. Okay, actually, this is not an attack. I just realized. This is actually just, yeah, it's gonna spawn a rock. That's the thing here. But I don't think we have that logic in here. So this is just, we have an adoration. But yeah, set ends at, yeah, that's what we need to do here. So that's basically there, but it's gonna be something happening in the update. So actually we need, like, if should well, what we want to do is we want to check if the time is, so spawn rock at, this is gonna be a timestamp that we need to set here as well. Spawn rock at, yes. So let's just add that state here. Now I'm noticing a difference between this system and the other. Is basically the state is instead of being separated into separate tagged unions, is actually just merged into this structure here. So actually, yeah, so spawn rock at is basically, you know, it was only part of the attack state, or and also the attack type, to be more specific, the attack type of throwing the rock, which makes sense. Now we're putting it like in this sort of global, maybe like for this instance of the monster. It's not really a huge issue, but I can see it being kind of, I mean, it is convenient. I can see it being kind of like I don't know. It doesn't really matter that much, to be honest. Yeah, so now we set this to whatever we need to set it to. What is that? That is gonna be what? T plus 1.2. So that is like, we need to have that here somewhere. Spawn rock delay 1.2. Spawn rock delay. There we go. Because now we have this timestamp, we can check for the timestamp. So we can say that we can get this guy spawn rock at is less than or equal to T. We also need to know if we have actually spawned the rock or not. So but yeah, so we should probably, yeah, we have to make this into a function. Should spawn rock, which we have to have outside of this, because otherwise the thing is gonna complain, but that's fine. Should spawn rock, let's get the context. Let's get no, that should be everything we need actually. And let's now do this and return this. We should also now what we can do is this. We can check if the spawn rock at is less than that. We could also, I mean, I guess technically we could set spawn rock at to like infinity in order to say that it has been spawned, I guess. Yeah, I mean, I guess that is what is the max value of F32? Like, when does it ever wrap around? Like, it has to be like, it's in seconds, I guess, so it's gonna be kind of huge. F32, what is the max value of F32? It's a lot. 10 to the 38. All right. I'm not gonna worry about that then. Okay. But at least that was in Rust. I'm gonna assume it's probably the same. Okay. So let's see. Yeah, so this would be the check that we need to do then. We don't need any other check actually. But I mean, it's still nice to have a separate function for this. If should spawn rock context, then we spawn the rock. Okay, and we spawn the rock. We will, yeah, we'll also do get cleared, and we'll set spawn rock at to infinite. No, it's 64 even. Oh yeah, 64 is gonna be even larger. It's actually insane. F64 max value 10 to the 308. Okay. Yeah. Sounds about right. So the number of seconds passed is probably not going to be more than that. Okay, spawn rock at blah 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 blah. Then we actually need to spawn the actual rock, and then we have to go here. We have to go to some sort of throw place rock. Here we're adding the rock. So here's the spawn rock function, which is doing a whole bunch of stuff. Let's copy that. Put that here. Alright, so we're making a new thing. Yeah, I should probably do this. Is that all we need, actually? T is, yeah, we have T. There we go. Destroy and touch. Yeah. This part is a bit weird. It's like it's like trying to prevent that, because the rock, like, and I don't even know if how I should handle this to this day even, because the rock is kind of it's supposed to be destroyed when it hits the ground, which is it is, and that works, but sometimes the monster is trying to throw, but since the rock is kind of spawning kind of a little bit behind the monster, sometimes the rock is spawned inside the ground from the start, or inside the wall, and it gets destroyed immediately. So that's why I added a little bit of delay here, which is this part here. So I'm running a function at some point in time. That's what this is doing. So it's running this function after quarter of a second that adds this that adds like the destroy on touch to the monster. Yeah, or to not to the monster, to the rock. All right, and we're also destroying on touch on for the player. Well, actually, what we're doing is we're modifying destroy and touch to be all instead of just player. So all means like ground, player, whatever. And we also have damage on touch, but we can block with the shield. Okay, cool. Then we have a bunch of stuff going on here. Yeah, so we are getting the animation container, the rock, and we are... So this could be like simplified a lot if we use the editor to add like an entity type for rock, because then we can just spawn it, and then it's gonna use like, because what I'm thinking of doing also is adding a way to define the animations on entities, and in order to do that, I don't want to force a animations property on all entities, but what I want to do is add a global properties that you can modify. So you have a set of global properties that are automatically added to all entities, and they can be changed on each instance. So each entity instance is going to be able to, so let's say you add, for the global properties, you add a animations container or animations data, or animations asset is called. So you have one property on the global properties that is a reference to an animations asset, and so now all entities have this property. It could be optional as well. It could be an optional property, but they should all have it, and that allows us to grab the correct animation instead of doing this, and instead of also having this animation container in the first place to do a whole bunch of weird stuff. Then we can actually grab it from the data itself to check, okay, we can grab the correct animations from the entity type itself. So if we have a rock entity, for example, we can just say, okay, grab the the animations that is assigned to the rock. So we can just add that in. And really, this whole thing here should really be put into a separate function, because it's I'm using it everywhere, and I'm basically copying this whole block every time, which feels really bad. But I have just, I've been in this kind of mode in this game, this project, that I don't prematurely optimize. I just copy and paste, just moving forward. But then, at this point, at some point you end up with a project that you have a whole bunch of places where, okay, now we're seeing the pattern, so now we can see where we need to sort of tidy things up. And so this especially is a pattern that happens everywhere. And so but I really just putting off moving it into one thing. Also, creating a physics body is also very terse, or not terse, the opposite of terse. It's not terse at all. So but yeah, anyway, so let's see. Yeah, but most of this should be fine. Let's see. Throw attack, get attack, get duration, fine. T down. Throw cooldown. Move this here and rename. Context entity. There we go. Monster. Okay. Yeah, this is just context entity. Okay, hitbox. Yeah, that's gonna be that. T. Let's just grab T as well. All right. This can be changed now with a new version. Very, very nice. Throw strength. Where did that go? Oh, that's in here. Interesting. It's only used in the spawn rock. We can actually remove this now. I guess we'll keep it for now. Until we can just remove everything in here. It's gonna feel so nice just removing the entire thing here. Throw strength. Okay, now we have that. Okay, hitbox, the only thing left here. So hitbox, well, if we go here, actually, all right, this should be the hitbox right here. If we check, here's the here's the thing. So let's go back now here and go here. So the attack hitbox is gonna be something. It's gonna be this. All right, and this one is, we can just say that. No, but you need monster type as well. Except you don't need monster type. So we can just pass undefined, I guess. Okay, and you also don't need that, so that should be good. Right, the body. Yeah, we don't have that. I mean, it's easy to get it. There we go. Direction is the direction, yes. So there we go. Unreachable code. Oh, so this is the hitbox. Right. Context. There we go. Oh, there we go. Formatting. That tells us that these shallow errors are fixed. Okay. Okay, so that is the melee attack. Throw attack. Yeah, we need to call spawn rock here. Spawn rock. There we go. That was apparently done. Actually, no, we don't need to call spawn rock. What am I doing? This is the pre. Yeah, since it's delayed, we have to spawn it here. Now there could be another, you know, what was I gonna say? Another pattern. But I think having update functions, checking timers in update functions should be fine. I was thinking of, like, technically, I mean, another pattern would be to create something here where you have a system that, you know, runs things in the state machine at a certain point in time. So you could have a list of functions that are supposed to be run at certain points in time. So what you could do is you could say context add delayed or add a timed function or something like that. Add timed I don't know, add timed function, and then that would be like spawn rock, and we do it at a certain point in time. So we say, because then also we don't really need to look at this timer. We don't really have to store a timer either. We could just say this is time plus spawn rock delay. Or we could simply say this. So we don't even need to add t in there. So we could just say, okay, in 1.2 seconds, I want this function to be called. Okay? Now the issue with that is, though, is that let's say the thing is that you are interrupted, that the monster is, so the attack is sort of interrupted. Let's say the monster is stunned or anything like that. Then it's going to be hard to cancel this now. And now you need some way of canceling that. And you actually need to maybe save the handle. I mean, I do like the pattern, but now you need to sort of save the spawn. You need to save like spawn rock handle. And if we are stunned and we currently have a spawn rock handle, we need to cancel that handle. So then we can say here, like, if check is stunned or something like that, and if we have a spawn rock handle, then we get the handle out and we say clear timed function handle, and then we cancel that. So that is possible to do it like that as well. I really like this thing because it's like, okay, if you just want to fire something that's gonna happen at some point, then you gotta do that. And then you're kind of replacing having to manually check this time with this more, I guess, focused way of doing it, or, you know, yeah. But you still need to keep track of the handle, and because if the monster is stunned or whatever, if you want to cancel it, you're gonna have to keep track of it. However, if you don't need it, then you don't actually need to store any state here at all. You don't need to store the timer, you don't need a handle, then you can just fire this and forget it, basically. That's what's kind of good about this system here. But yeah, I'm not sure actually. Also, now this becomes a problem though, because the context, well, the context itself cannot really store this. I guess it would have to be something that's stored in the system. Like it could be stored on the entity itself, I guess. Yeah, it should be stored on the actual entity as a sort of. You could have like a time function component, time function container basically, and so you have like the time functions, and those are, since we're gonna be able to have handles, they need to be like in a map. I mean, we could just have like an ID array hash map and store like state functions in here or something like this. Yes. And then we can, clear handle. Handle is now this, and yeah, it's just gonna be like, so this would be a component that is added to the entity, and then this function would just add a new function in here. Actually, we would need a separate thing, a time function. So run at function we can pass the state function there. All right, now the only thing I'm thinking here is, no, that should be fine. Yeah, and then the state machine update function can handle if we actually should call this or not. I'm just thinking if this is a good pattern, if it's how do you say it? If it's good enough to just replace this simple timer thing, but it is an option that we can do actually. We can say we can even have an update function in here, and well, for one, this would just be functions map and then just remove handle, or whatever it's called, like delete, or I don't remember what it's called. Why am I not getting this? Oh, because this is like L. There we go. What is this called? Remove, delete. Oh yeah, swap remove, that's right. So we don't really care about the order, we could just do a swap remove. Why do I not have this type? It's about time to add this there. Whoops. Alright. Okay, and then let's see. So we just swap remove, and that should be everything we need to do there. This doesn't even have an error state, so that's good. Okay, and then here we can just loop through timed functions values, and we get the thing out, and we can check if I don't get the type out here. Oh, this is a okay. We need to check. You are a timed function now. So we need to check if run at is less than or equal to t, which we do need to pass along. Actually, we need to pass in a context. Yeah. There we go. And if that is the case, then we run it. We actually need to store a list as well. We need to store... I don't want to allocate anything. How many would we have? Well, maybe we do need to allocate. Oh man. Cause I might actually want, I want to remove the function once it's been ran. So let's just do allocator get singletons get const, and we'll do well, how would we wait? No. Well, yeah. Time handles to remove. Right. So this would be array list of IDs. Let's just init with capacity. Yeah, we'll init with capacity, and the capacity is the size of this or count, whatever it's called, count. Yeah. All right, so then we don't need to worry about that. So we do this here. We run the function and we add this here. Append assume capacity. Why do I not get like the type here? Out of memory. Ah, I see. Let's ignore that. Okay, append assume capacity. The item is, oh yeah, now we need the, okay. This always happens. You always start with looping through the values, but then you always need the ID as well. So I'm just gonna make an iterator, and we will say next entry key pointer. So let's add that there. All right. And then I might just end up using this, and we'll see how good it feels to use. Okay, because I've come so far with it. I saw a path and I took it. All right. All right, and then at the end we'll go through every handles to remove. Items. We get an ID here, and we will call clear handle ID. I guess we'll call this handles to clear. Okay. Great. I guess we also need to deinitialize this there as well. There we go.
And then we do need to deinitialize this array hash map as well. I mean, I guess, sort of, maybe. Do we do that? What happens if the entity gets removed? And these functions are not going to be called, and there's going to be a leak as well. So yeah. So if you kill the monster while it's throwing a rock, or while it calls this time function, then it's gonna be a hanging array hash map here. Yeah, that's the thing. That is a thing. I mean, we could have we could set up a listener on when this is removed, and then we deinitialize it. So that is very that we can do that. But yeah, with this system we could just have this system, and it should work, right? Yeah. Oh yeah, and we also need to add one, like if we add a new one. Oh hey, Over B man, long time no see. How's it going? How are things going with you and your project? Yeah, it's going great. Well, I mean, it's not going fast, but it is going forward, and I'm learning, a lot about SIG and game development. So that's good, because that's kind of the point of this whole project here. Yeah. Yeah, we'll see what's gonna happen, but I'm sticking with it, and yeah. So yeah. I don't remember. Were you also developer, or sorry? Do you have a working game loop, or are you in the weeds still? Do you mean design wise, like? Because I would say I have something, but I wouldn't say that it's like how would you say it, like genre breaking or anything like that. It's basic. It's a basic sort of 2D side scrolling. Like 8-bit hack and slash, or whatever you want to call it, right now. Yeah, you can play it. I actually have a link you can use to actually test it for yourself if you want. Because I compiled it to WebAssembly and put it up on a website. Let's see if it's. I'm gonna see if it still works. Yeah, so you can go. Well, you can go here. I'm not sure if the gamepad won't work in this version. I don't think. There's some issues with like the WebAssembly version and getting gamepad to work there, but you can use the keyboard, and the controls are stated there. Yeah, I can show you the website here real quick, because it's also really nice to have a place where you can actually show the thing easily as well. Why is this not showing up
in my... Oh, there we go. Okay, yeah, so here's running in the browser. Now the FPS might not be the greatest, but there is... whoops. Oh yeah, pressing space might not be the best mapping here. Okay, I probably need to fix that. Man, how did I not notice that before? Maybe I never tried jumping. Yeah, here's the monsters. Love the look. Okay, cool. Thanks. Yeah, I think I mean, I was thinking of doing like, because I'm not really a graphics guy or anything like that. I'm more of a programmer. So what you see here is like programmer art, and but yeah, I do like the 8-bit style, so probably gonna stick with that, and probably just gonna. But I feel like some of the things like the characters, I'm not really good with characters. I think I'm more maybe better with the environment, maybe. Yeah. Yeah. Thanks. Thanks for stopping by. Have a nice day. Let's see. We'll see how far I get next time you join. Yeah, characters are hard. Alright, see ya. Okay, let's see. Yeah, time functions. Okay, yeah, so we also need like add time functions. We don't need, well, what we need is a, well, I mean, we just need a time function, I guess. But we do, yeah, let's just add function and, whoops, function, and then run at, and we will add or put, I say put. So yeah, we need to generate a new okay, let's just pass allocator here. We need to do allocator. Come on. It's like my subconscious does things, and then yeah, whatever. Key, yeah, so this is just, you know, init, it will init a random ID. That should be fine, you know, it doesn't really matter. And then we just need something there. Oh yeah, and then we need to, yeah, we need to return this ID as well. That's right, so we return the handle. Whoops. No, so we create this here. Init. We use the ID and we also return it so that we can use it. Alright, and then the value is going to be function is function and run at is run at. And we'll make this public. I'm gonna move you to state machine. All right, we need L. Okay, it's gonna be interesting to see
how this pattern will work. Well, how well it will work. But it's nice to have it because it's a common enough thing that I want to maybe, you know, have it here. It's just going to be a bit, I guess, it's a different pattern. That's what I'm worried about. But we'll see. Okay, so we're adding, we are updating, and we are clearing. Okay, so that's the functionality that we need. Now we need to actually run this. So here we have our state machine. We also, so here's the context. We also need the timed functions. Now this would be like a try get, I guess, on the time functions. Of the entity. So if we have it, I guess we can do this. If we have this, we get time functions, and then we also update those. Now what did you need? Context. All right, so we have that. Now, also one thing that is important here is that you probably don't want to set a new state in the one of the time functions. So, yeah. Because, yeah, that's not really, that's, well, maybe you can actually. No, I was thinking of the post function. That's right. The post state function, you can't set another state in there. That's not gonna be sensible. Okay, anyway. Okay, now we have time functions. Yeah. And yeah. So it's gonna be this pattern then instead. I mean, yeah, sure. That should be fine. But then, yeah, so, yeah, we can add, where's the context? Add time function. So we need a function. Because it is kind of, it is a state function, so it is very coupled with the state machine thing. And then we have like the delay. All right, and then we get the handle back. There we go. All right, and then we just call well, what we need to do is we need to say if we don't have the if we don't have time functions, then we need to create it. Yeah, that should be good. Okay. And then we need to grab it. From get time functions from entity. I guess we could just call get at this point. There we go. So this is time functions. All right, and then we return time functions dot add. Oh, we need allocator. I guess we could have a function here, allocator. I guess that's convenient. Convenience function.
the function is function, and run at is this plus delay. There we go. Okay, and then over here we can now, yeah, now we have this function. We get the handle back. We can cancel it if we need to. At this point we don't really have stunned phase, so we actually don't need to do that. Oh yeah, we also need a clear time function as well. Clear time function. And this is the handle. And we will say if, well, time functions is try get this or else return, and then this would be, oops, clear handle. All right. Okay, so now technically we could, you know, implement this way if we want. We actually don't need to store the handle at this point, so we can just remove. I mean, okay, yeah, no, wait. If actually we do need to cancel it if we die. Yes. Okay, so maybe this returns a bool to say if we died or not, or we can just check if we died. If we're dead, we want to cancel, and if we have this, we cancel it. I mean, I guess this would be applicable to any update function. It's not only here, so we could add it here as well. We could say, yeah, we're clearing out the handle if we have it. Okay. Yeah. Okay, and that makes it so we don't need to have this timer anymore. There we go. Okay, and let's see. Wait. It's beginning to be a lot of stuff in here, but it's all the good thing is that all localized into this monster, so we don't need to, you know, look at that. If we want to change the state of some other monster that is simpler, we don't really need to look at all this, because that's what we had to do in the previous system. So that's a win, I think. Alright, so now Spawn Rock at is no longer a thing. We have Spawn Rock handle instead, which is a UUID. Or actually it's an optional. We'll set it to null. There we go. Yeah. And even if the handle doesn't, even if the handle is like invalid, this won't actually crash or anything, because if we don't have time functions, then we don't care, we just return. If the ID itself doesn't exist in the map, swap remove doesn't care, it doesn't crash, it just returns false, with that we don't really care about. So we don't really need to clear this handle either. We can just, you know, reset it if we have another yeah, if we need to set it again. Okay. Let's see, the melee attack and the throw attack. Yeah, so now we can do that. Cool. Let's see how. I mean, we can still do the old pattern as well. There doesn't nothing preventing us from doing that. But now we have this new way of doing things as well. Yeah. Okay. And oh yeah, and also now we don't do this, so we don't actually have this here anymore. It's kind of hiding the fact that when we do the throw attack, we actually spawn the rock. However, it is in here in the spawn rock. We do see it here, so it's moving it from update to the pre function. So I don't know, but it kind of, you know, it kind of hides the fact that during the sort of duration, I guess you could say, of the attack, it's not something that happens in pre, it's something that happens during the update. So yeah, it's also if you would change the state to something else during this, like let's say you're stunned or whatever, then we have to deal with that here as well. I mean, I guess that could be part of default behavior as well, but it's just the fact that the time functions doesn't necessarily have the same lifetime as the state of throwing, doing the throw attack. It lives like outside of this state, so yeah, it's a little bit different. But okay, anyway. Okay, what now? I think, yeah, just okay, yeah, but now we should the spawning rock should execute at this point. The melee attack also should work. Do we? Yeah, the only thing left I think is here, like when actually executing the attack. So the melee attack should be done. The thing that we should do is this. So, oh yeah, we have play sound as well. I forgot about that. Okay, I'm just gonna forget about that for now. But now we're setting the state to throw attack. That's right. There we go. And I think we can remove this. 0.6, 0.6, 0.6. Spawn rock play sound delay 0.6. Okay, I'll just keep that there to know to keep it there, so we don't lose it. Okay, now let's try it, I guess. And I'm gonna have to look at, you know, optimizing a little bit space-wise for this, because there's a lot of things going on here. I knew this would be a lot larger than the other monsters, but because of the complexity here, but I was still hoping that it could be maybe smaller, but yeah, a lot of the space that takes up is gonna be things that we can actually put into functions. What is the issue? What's your problem here? Unable to value comp time expression. Oh, I see. You need this to be comp time, you say? Well, you need the result to be comp time, actually. Yeah, okay. That's maybe, well, okay. Could we do this then? If we say if r is less than 0.5, we do melee attack high, else we do low. Can you set that to a variable? If it's constant, could you do this? Does this work? Fractional... What? Fractional component prevents float value 0.5 from coercion to type U8? Wait, why is this U8? Oh. I changed the thing. Okay, yeah, this is float. F32. There we go. Okay, value with counter. Okay. What if we put the expression in here? Will that be better, or will that still be an issue? I mean, I know how to solve it. Yeah, okay. We have to put the if outside. We have to put the if here and then call set state. Sometimes I wish it would do this, you know, automatically. I don't know. Else. Oops. Set state. Like expanding this automatically. I don't know. It just. This should work, right? Because now it knows, like it has the code space to put these two different things in there. Okay, here we go. Expected physics found. Okay, so you need to be a constant apparently. Fine. What? Expected type info tech. Oh, right. The attack type. Oh man. No, but that's, it doesn't even use attack type, so whatever. Do you use attack type? Yes, you do. Yeah, do. Okay. But it only cares about high. So this, yeah, this is for the melee attack. Can we, if this, okay, let's just do, if this is high, oops, then high else low. I'm just gonna do this. This is transitional code here anyway, so once we get rid of the old thing, we can improve this. What now? Direction, founder, okay. What? Okay, so you need this to be constant. Is that correct? Okay, yeah, so we don't actually, yeah, that's a win. We don't need to clear up manually the timer. It's gonna be done by the timed functions machine. Okay, here we go. State machine, missing field. What field are you missing? This field? Well, we set you to empty, so there we go. Okay, what's your issue now? Expected 4 arguments, found 5. Type name, params. Oh, okay. Expected. Oh my god. So I have to do this. Or. Man, these errors are a pain in something or other here. Because it's like, yeah, it's a. No, it's not a slice. It's a point. It's a pointer to an array. No, it's not. Can I do pointer cast, please? There is some way of setting the type here. Cannot infer layout. Okay, so what if we do this? Is that the correct thing to do? I just don't wanna have to spell it out. Expected type slice found pointer to constant. But that's a slice. Okay, what if we do this? That has to be a slice type, right? Slice of non-array type. What? Okay, so I have to do this. No. Wait, expected comma after argument. What? I don't understand. How do I get the slice type? Why can't it? This should be a slice. I'm slicing it here. What? Or is this expecting? It's expecting a type. Can't you slice arrays? I thought you could. Maybe you have to have the pointer. Maybe it has to be a pointer. But now it doesn't know the length. Maybe. Found. Okay. What if we do like this? Pointer cast. No. Discards const qualifier. Okay, is that the issue? It needs to be like it needs to be const. So if we do this, will it work now? Maybe. I mean, this is the problem here. I would think the types are always I mean, I guess technically you could have a comtime mutable array of types, I guess. Okay, maybe that did it. Invalid number of parameters 1 expected 1. Huh? Okay, now it's validating the function and says that it's the wrong parameters. The issue is that I'm not seeing which function it is. So this would be, let's see, this would be like the valid state here, and because the error header is empty. So the issue here, we don't really have any information here about anything. Where's this called from? It's called from here. Yeah, we don't really have any information here. I don't know if you could get information from the pointer at this point. I mean, it's comp time. So could you in some way get some information about the pointer? I mean, technically we should, the Zig should be able to have that information here. We should be able to map the pointer to the function. It should very well be able to do that. So but the problem, I guess, is that we don't really have, I mean, we have the new state. Yeah, we have, maybe we can make like an any thing there. We could do format compile print any new first state. And so we get something here. Unable to format function body type. Use for function pointer type. What if we do this? No. So what if we do type of state, type name, that should be doable. Okay, function state machine context, invalid number of parameters 1 expected 1. Okay, so there might be something wrong with the validate function. Right. If, oh, it's hard coded here. Okay, expected, whoops, expected parameters length. Good. We're trying the validation stuff out, so that's great. Okay, so now we have some other errors. This has a error apparently. We're gonna assume that this is not gonna be an issue. Okay, apparently now it's done. All right, let's try these bastards out here. See if they work as before. The only thing that should be, well, I know that the jump doesn't work. Okay, there we go. It's throwing a rock. Awesome. And it's doing attacks. Cool. Is it hurting me? Okay, I'm gonna try and take damage. No, it's not hurting. Alright, let's enable the attack. Draw the attack debug boxes so we can see what's happening. Yeah, it is there. Interesting. Why am I not like taking damage? Also, it should follow the it should follow the entity, but that's easy enough to fix. We just have a flag for that here. Follow source, true. There we go. Not sure why it doesn't hit the player. There could be something wrong here with the attack system. Let's see. So is enabled. I'm gonna check this. Is enabled hurts at is less than or equal to T. So that means it should have paused that, so it's hurting. Right. I'm gonna do this. I'm gonna go to the debug, to the draw, and then draw attacks. Here we go. We're also gonna check if the attack is enabled. Was that the correct thing? Is enabled is on the attack component. Is enabled, and we need T, so we actually need T here as well. No, if it is not enabled, we continue. There we go. T there. I'm just gonna wing it and see if it compiles. Yeah, it should compile. It took too long to spit out an error. No? So it's apparently not enabled, which explains quite a lot. But why is it not enabled? This should be set to true, and is it not like is this not working? Hurts at. Let's check. Hurts at. It's the same. Yeah, it's the same. Why is it 32? It should be like 64, I think. Oh, so it doesn't complain when you're adding a 64 to a 32? Interesting. Okay, that's one of the few cases where it actually doesn't complain about different types. Okay, so why is that not working? Hurts at is less than or equal to T, right?
I mean, it could be enabled. It could be that enabled is set to false, I guess. But yeah, that only happens here if we are blocking. Wait. Is this supposed to be called with the target? That doesn't make sense. No, it's the player. Wait, but the player is the target. That's right. That's right. Man, time really flies. I was planning on not. I was planning on quitting some time ago, but I got lost in this. Yeah, a bit of a hiccups here, but we do sort of, yeah, it's like implementing, it's nice to implement the backing systems of these things, like taking the time to actually going in and optimizing the sort of, yeah, the way the code is written and the way you read the code. Now, yeah, granted, there is a lot of stuff in this state machine, but that's because this particular state machine is pretty complicated. So that's a symptom of the complication of the machine. But I don't want this complication to spill out over everything else, which is what the previous system had. It's like baking in all behaviors in one place, which granted we could have moved a lot of stuff out to the entities themselves, but it was still kind of this inverted shell way of doing things instead of having everything in here. So now it's very easy to go in and, okay, because the thing is, let's say I wanted to, well, let's say when the rock is spawned, I want to do something, or during the spawned rock, maybe the monster takes double damage or something like that. Now it's very easy to know where to go in order to actually do that, because everything is in here in the same place for this particular monster. So you can just go into this monster, look for the thing in this state machine. You don't need to jump around between the specialized functions in override classes or whatever, and then also look at the shell class or the base class to look at where is this happening. Everything is found in this place. So I really like this way of inverting so that the entire thing is in here. Now granted, there are some particular things that are outside, like creating the attacks, things that are not this entity, like spawning, the loot when you die and stuff like that. But there are pretty few things that are actually outside of this system here that is to do with the monster sort of behavior, or what you want to call it. It is a little bit more than the behavior here. Well, I guess it's more like all the things that the monster how it could affect the game, I guess. But it is a state machine for the monster. Some state is very simple here. It's just the attack is way more complicated. But I think a lot of things here could be like, this is such a common pattern that I'm gonna put this in a separate function. This as well, like creating just a simple physics body, is so much text, and so yeah, that's also one thing. Yeah, this part just feels way too much just for this simple, explanation of this thing. Is just that after some delay we want to enable destroy and touch for all types. Yeah, that's what that's doing. But yeah, can we get something working here? Let's see. We could maybe move this thing out from here. It's like maybe I'm contemplating in putting those things that are maybe not really related to the state machine per se, but side effects of the state machine is probably good to put those into functions, and because then the state machine itself, you only see things that are sort of related to the state machine, and it also fires off side effects sometimes. So yeah, I think that makes sense. All right. But what am I looking for? So yeah, the melee attack. Why is this like not enabled? Is it the hertz at that is the problem, or is it something else? So what I'm gonna do is I'm gonna go into here. I'm gonna look for is enabled. I'm gonna say that. Well, actually, I'm gonna go in here and say if it's not enabled, why attack is not enabled, and we're gonna say hertz at is this, T is this, and enabled is this. So that will give us everything we need. So we got hertz at, we got T, and we got enable. Let's go. Please don't be a compiler error. But it's really nice to get working on this new thing. I think this is a way better system. At least that's how it feels right now. Like, I'm very glad that this still sort of feels like it's working. Okay, we got some leaks, sure, whatever. Attack is not enabled. Right, hertz at is 3.6. That doesn't sound very good. Okay, well, T is 2.60. Okay, so enabled is true. That is a good sign. So it's the hertz at. That's the problem. Okay, and there we go. There it should be true, except it's like not true. So what is going on? So here we can see that hertz at is set to 2.67 plus something to give us 3.59. So that would be almost like one. It's like 0.9 or whatever. But when it's like the attack is sort of done before. It's like just before it's happening. That feels almost. Yeah, just before this is done, it's removed. So there's something weird going on here. Should destroy at. What would that be? Then maybe destroy at is the thing. Yeah, but this is like hertz at plus duration. So it should not get destroyed at that point. I'm confused. And here you can see it's like 9. It was probably this one, 0.92. And hertz duration is 0.4. So destroy at. I mean, we could log that out as well, I guess. Is destroyed. Oh, sorry, I'm getting a call. 1 second.
Alright, so let's see. I need to go soon here, but let's just power this through here. I would just want to fix this. Actually, yeah, just also I want to see what is destroy at as well. Let's put it next to T so we can easily compare. And I want it here as well. It's not gonna change, but it's nice to see it. Okay. Oops, I played the wrong thing. Well, I guess we can check if it's compiling or not. There we go. It's quick enough to start here. Alright. Please attack. There we go. Attack is destroyed. There we go. Attack is destroyed. Interestingly, we do get another attack. I think it was quick enough to attack again before I pressed escape there. But we do get one attack is destroyed. Time is 4.1, so technically it should... okay, this is weird. It's like jumping. Okay, so maybe it was enabled for like point whatever seconds. 0.3. I should have seen that, and I should have taken damage as well. Destroyed 4.1. A 3.8, 4.1. I mean, that sounds good. That's like 0.3. And what is the duration here? Yeah, it is 0.3, so that is correct. But for some reason the update stops happening for that duration here. Like, no, it's not. I'm stupid. But it should be enabled at that point. It should actually be enabled. So I'm not sure why we're not seeing it. Like, it should show up as a square there. Maybe something is wrong with the hitbox. No, it did show up before. This is very strange. Very, very strange. I did enable this, yes. If it's not enabled, we continue, and then we draw it. So it's like it is actually enabled for us, yeah. So we are going down here. Enabled, right? Let me just try this again. Okay. Is destroyed. Okay, there we go. It is enabled. So why is it not showing in the box? Or why is the box not showing? We have an enabled attack, so why is this not working here? We get the attack. We get all the attacks. We only care about attacks. Looping through all attacks. Is it like removed from the... No, because then it wouldn't show up in the attack system, which goes through the same process here. Yeah, this is really weird. Is it like instantly neutralized or something like that? We're neutralizing it, which disables it. right? It could be that. It could be that it's immediately disabled, and so so actually what we would want to check here is, well, okay, let's actually make it, let's do a test, because in that case, if I go close and then go away, it should show a box. No, it's not. So it's not, it's like, what? But then also, if it was neutralized, it would not be enabled, so I don't understand. Yeah, it is enabled, so I don't understand why it's not showing up. Is the hitbox weird? Is the hitbox not correct? Wait a minute. Oh, I see, I see. I know what the issue is. Oh my god. Okay. So the issue why we're not seeing the hitbox now is because I changed something when fixing something before. Well, quote unquote fixing. Okay. I did this. It should follow the source. Right, it should follow the source. Right. Well, that made it so that the coordinates of the hitbox changed from absolute to world coordinates to relative to the thing coordinates. Okay, there we go. But we're still not taking damage, but that's fine. At least the mystery is solved. Okay. Let's see if we can quickly fix this. So if we make this relative now, this is now relative. So the hitbox should be, we can go into the offset, and we don't take into account the body position. Where do we do that actually? Rotate, rotation plus offset, scalar distance. No, that is the offset, right? So we're getting the offset, and then we take the center there. Yeah, we shouldn't do that. We should just grab the center directly there. And we can even do this. Let's just do this, I guess. Center is U. Size. I don't know. Maybe that's not better at all. But yeah, that should definitely be the center. Hello, Palera7. Have a nice day, you too. Thank you. Alright. Let's see. Now it should work, right? Yeah. And if I do that, then it follows the thing. Okay, cool. What now is the question? So the hitbox looks fine. Why is it not hurting the player though? Yeah, it's the first monster attack that we're implementing, so it would make sense if we haven't encountered this issue before. Is it blocking is the question? No, because if it was blocking, we're neutralizing the attack. That should disable the attack. That should remove it. And we can test this by, it should remove the red box as well. So we can test this by actually trying to block here. Yeah, and there you can see the red box disappears. If we move and we don't block, then it's there. Okay, 1 second, getting a call here again. Alright, I have to go in 1 second here. Let's see. Yeah, okay, so why are we not damaged? Can damage target. Is something wrong here? We are enabled. Well, we can just do is enabled as well, I think. But then we need T as well. Fine. That's fine. I mean, that should be better. We should be, you know, that this should be a good check. If we are not enabled, we return false. Very important. We also check if we are inside of this list. Then we already are hurt by this attack. We return false. If the length is more than the buffer length, we return false. So this could be a thing here, actually. Because what is the buffer length? It's 32. And so... Okay. If it's more than we could do this, then we return false. So this should return true. Then we append ourselves there. We try to get our health from the player, which should exist. I mean, given that the target is the actual player, it should be. I mean, we are doing the shield block, so that should work. Then we're hurting with the damage, which should be 1. And we are hit, which does something. We end the attack, whatever, yeah. Okay. Right. Yeah, I don't know. I have to fix this, so I will do a to-do. Figure out why the player at this point does not take damage. Alright, cool. But yeah, I'm out of time, so thank you very much for watching, anyone who joined me here and chatted with me. And yeah, I hope to see you next time, and have a nice day, and see you.